All right, everyone. Welcome. Hello. My name is Asher, and I will be hosting or emceeing today the IoT Edge Cloud and Cyber Showcase. Say that 5 times fast. And joining us today, we're going to have a pretty good lineup of companies and panelists. So we're having two sessions. They're not really separated by any common theme other than IoT, Edge Cloud, and Cyber. So we're seeing software, a lot of software with some touches of hardware in the mix, but mostly software. And so, just to give everyone the spiel, for those of you who are joining for the first time, basically, what is the vision of Deep Tech Showcase is to help these companies that are developing cutting edge dual use technologies and actually help them come to market. So, and with that, it takes quite a few different actors. It takes startups who are actually developing the tech, obviously, stakeholders, whether it be air tech scouts, whether it be government or corporations, and lastly but not leastly, investors to fund the whole project. And we do a few different activities, one of which is the showcase events. You're on one today, where we're going to have about, I think we're having 8 or 9 companies present, and they're going to present various different technologies, all within the software slash with a hint of hardware, with a little taste of hardware space. And then we're also, we're going to have the panelists introduce themselves, but it's mostly going to be pitches followed by Q&A for the whole event. And then secondly, we do guided introductions. So what that is if you're on this call and you see a company you like, feel free to reach out to me. I'm always happy to make the connection when possible. And so always happy to make connections, and that's the goal of this whole event. It's not necessarily just an event for people to get their name in lights, although that's nice. It's always nice to get your name in lights. It's also important to actually see movement, and we've been lucky, actually, or not lucky, but thanks to everyone involved. I mean, there have been some really great success stories that have come from these showcases recently. These are our two upcoming events, so Energy and Clean Tech and Industry 4.0. Stay tuned. Hoping to see everyone here there as well. And with that, I think we dropped a slide. I'm going to quickly pull it up. But Yoav, do you want to start presenting a word from our sponsor?
So, hi everybody, great to be here again. You have Joe Sadan, and I'm the least, as always, as I like to say, I'm the least interesting person at this event because I talk about the government and the non-dilutive funding side, and the rest are amazing panelists and awesome companies. So, my goal is to let you know where we fit in this process in 5 minutes or less. And if I go overboard, Osher will kick me out, or everybody else feel free to shame me on LinkedIn publicly. But right now, what's happening in the government space, it's a little bit of, let's say politely, there's uncertainty. There was government shutdowns, SBIRs that haven't been reauthorized yet. Nobody knows where's money's gonna come from. What are the priorities that are changing? So at Eagle Point, we made a strategic policy about 2 months ago. We are no longer counting on SBIR, Small Business Innovation Research, as a go-to mechanism, which means if they do come back tomorrow, awesome, we just add them to the plate. If they don't come back till October, that's also okay because we are no longer counting on it as a funding mechanism that's primary for the clients. What this means operationally for every client we work with is a dual approach. One side is finding every contract vehicle, broad agency announcements, if needed, sign my companies to a consortium that actually costs money. We will pick up the tab if the client is engaging in a long enough timeline and get them behind the paywall, and then help them navigate within that system to find other transaction authorities or other buckets of money. And at the same time, use Osher's team to go and actually do the biz dev and the network and find the office that could use the product that can sign the letter of intent. Because some startups are just trying to raise in 12 to 24 months. Others are trying to get dollars in the door. Each client needs different things. We are the ones that are essentially doing it. So, Asher, if you can move to the next slide.
I think I only have one here.
That's it. You didn't
Wait,
get
I
many.
need to get Brian. If Brian wants to pull it up, because I don't see it in my anything different in my inbox. There we go. Brian's sharing now.
So I promise we're just gonna go over really cool, interesting stuff that's happening, not We've been doing this for a while. Next slide. The cool parts again. Next. Um, next. Next. So here you can take a look if you can see the screen is just like the networking platforms from the Department of War and the general government that I was able to find and I'm registered to in 7 minutes. Somebody needs to mute. And the thing that you're seeing here is they're moving in a shorter timeline solicitations, meaning we have something defense innovation unit style. All right, it's closing in 3 weeks. So that's one thing. And if you're not checking it literally on a daily basis, then you will not have the time to find the solicitation, vet it, and then submit. So what we do at Eagle Point when the clients work with us is continuously look for those, bring to the client, and then the turnaround is really short. But DevX Autonomy is from the Army Applications Lab. Below is Vulcan from SOCOM. Awesome opportunities open daily. DefenseWorks, IC Works that's closing on February 27th. CISA has millions of dollars in projected forecasts and broad agency announcements and different programs. Softworks as well. Tradewinds have two programs that close on March 5th and 6th. So the government dollars are there. That's the thing that we were mad about. Like, where is it? SIBRs are $3-4 billion. The National Defense Act is like $900 billion. Usually there's 60 to 80 billion dollars that goes on research in the private industry. Fine, take away the primes. There's still $30 billion that goes into these procurement, prototyping, experimenting. So just an example of how these agencies are now shifting to, I have an end customer, the end customer has a problem, I don't need a solicitation and then the program, and then 2 years it goes to another person that then might experiment it. And 15 years from now, we might get a new sock that's like 3 ounces cheaper. So the point is find an end user, show a problem, demonstrate that you can show it. Next slide, please. So there's SOCOM, Army Open Solicitation, multiple Navy BAAs, CISA project procurement. Next slide. Just an example that is relevant for the people in the audience right now, right? I'm not showing like advanced materials. I'm not doing space stuff. So there's model training and validation, generative AI, autonomous model retraining, adaptive learning, agentic AI, really advanced cyber capabilities, etc. These are open, available right now, and there's the partnering platform. So we also need to help coach the clients what to tell the agencies and how to get it funded. Next slide, please. And it's just also to show you there's a lot out there and make you like optimistic. There is government funding, it's just more complicated and a little bit more annoying to find it. But me and Asher went on like days long of rabbit holes and we find dozens of programs. So electronic warfare, UAV operations, jamming environments, surveillance and reconnaissance, build, program, fly, systems in innovation design, swarm and maritime environments, a bunch of stuff in autonomous systems. Next. And then CISA literally has a partner platform. Here's what we're going to announce. Here's what we're going to pay for. That's $250,000 and above. There's small business set-asides. They're funding and budget for prototyping and services and experimentation. They have like projected procurement that they have 6 months into the future. We didn't have that when we only banked on SIBRs. Next, please, if that's not the end. Tradewinds AI, because again, it's like an AI and cyber showcase, right? It's not the only stuff that's out there. Tradewinds AI, Chief Digital Office, they're trying to bring in AI into the government and the Department of War. So unclassified network modernization, and then AI-enabled software development coding capabilities, if that sounds familiar. It's kind of like the stuff that has been buzzwording around and like the open, these type of stuff. They're looking for something that they could use. Really easy submit at the beginning, like several pages of a white paper, and then you move on based on how like the program of merit and how good your tech and company is. So there's a lot of stuff out there. What we do with companies in the past, they said, well, I know their SIBRs, is Eagle Point the company to do it? Well, Now there's no SIBRs. And what we do with every company and the people here in the audience, I'll send over my email and my kind of book a call with me real quick, and then I'll be done. Basically, every client, we understand what you're trying to do in the next 12 to 18 months. Then we'll come back and say, listen, if these are the goals and that's the amount of funding that you'll need, um, here's the pricing to do this. So I'm not asking you to sign a contract with me on the first call. The point is to identify the path forward with your goals. So next slide. I think we're pretty much done. Yeah, you can do like a one-off. We can do a path. Never mind. The rest isn't as interesting. Bottom line, there's a lot of funding that's out there, and plus Eagle Point, we do both the network and biz dev and actually find the dollars in programs. So I'll send the email and the link. Feel free to book a call with me, and that's pretty much it. Almost 5 minutes. So
Cool.
thank you, thank you everybody, and
Yeah,
feel free to reach out if you're interested in getting a quick meeting.
absolutely. Thank you. All right. With that, what we're going to do is we're going to go around and introduce the panel. We're going to go one by one. Please just, give us a little bit of background on yourself. Doesn't have to be too long. I think about 30 seconds each person. And then we can, get on with the presentations. So we're going to start the circle with Jonathan. You want to go first? Jonathan Wu.
Hi, this is John from ITIC, the venture of E3 ITRI, one of the largest research organization here in Taiwan, and some of the notable spin-off you may heard of, including TSMC and UMC. And we are interested in C to Series A deep tech startup. Thank you.
Absolutely. It's a pleasure having you. Next up, we're going to have Baha. You want to go next?
Oh, no sound.
Yeah, we can't hear you. Okay, we'll circle
Yeah.
back.
Oh,
Oh, there you go. There you are.
sorry. Bahara Desai, Technology Scouting Director for BAE Systems. So I don't know if you're familiar. BAE Systems is one of the prime contractors in defense and aerospace, and one of the technology scouts for them. And looking forward to the presentations today.
Absolutely. It's a pleasure to have you. Next up, Lindsay, you want to go?
Sure. Lindsay Aspergren. I'm based in Ann Arbor, Michigan. I'm a special partner with NTT VC. We're a $500 million fund making investments primarily in the US, networking, services, anything that's has kind of agentic themes and AI. Nice to meet all of you.
Pleasure to have you. Next up, Marissa.
Hi, I'm Marisa Alma McGinnis, and I am a full-time investor. I'm in a couple of venture funds also, and I'm interested in defense, healthcare, and AI, and I invest for myself.
Perfect. Han, you want to go next? Hanko.
Sure. Yep. Hanko here. USACO Group is my company. I'm a president CEO. And first of all, deep tech space is a good platform I believe in. So I made a lot of good connections and was able to make some positive results out of it. And going back to my company, USACO Group, what's unique about it is that we have a presence on different parts of the country and overseas in Asia as well. So, including we have office in Los Angeles, Dallas, and Midwest, and all the way to South Korea as well. Actually, which I'm at right now. I actually happen to be visiting. Anyway, we have a strong interest in AI, deep tech, as well as other innovation. So, looking forward to work with you, and for those who are going to present, please good luck. Thank you.
Absolutely. Pleasure to have you. Kathleen, you want to go next?
Sure. Kathleen German. I'm located on the West Coast outside of San Francisco. I'm with Dow Corporate Ventures Group. We are a global manufacturer of chemicals and materials. And I'm a tech scout in the group. What we scout for is hard tech. Granted, IoT and robotics can be an adjacent area, but I look at how they fit into advanced manufacturing and materials discovery. Happy to be here.
Sure. Happy to have you. And I believe that oh, Hyundo, you want to go next?
Sure. Hi, everyone. I'm Hyundo from Honda Exoto Ventures. We are a CVCR for Honda Motors focused on mobility, manufacturing, sustainability, and robotics. And looking forward to learn more about all the companies. And thanks for having me here.
Yeah, absolutely. Michael Lawrence, you want to go next?
Absolutely. Michael Lawrence, Sentiero Ventures. We invest early stage B2B SaaS with AI as a core value proposition. Looking forward to all the presentations today. Thanks.
Nice. Absolutely. Pleasure to have you. Let me just make sure that I'm not forgetting anyone on my end. I think I got most of my bases covered. Brian, speak now, forever hold your peace. All right, that's it. We're good to go. And if some folks join, we'll introduce them as they come along. But now we are going to get started with Veritech Systems. Feel free to start sharing your screen whenever you are ready. It should be that you're able to share.
Yeah, do you see my screen?
Yep.
All right. Hi, everyone. My name is Michael. I'm at Veritech Systems. Veritech Systems was built on a belief that specialized swarms or specialized teams of robots will be more efficient than homogeneous or the same teams. For complex problems, we need specialized teams with different team members with different specializations working together. We basically believe that the robotics industry is building for controlled environments, right? Where there's cloud, where there's infrastructure, but for edge case environments like the open ocean, military, and border terrain situations, you don't have that safety net. And generalist robots can't really thrive because they don't have access to the cloud. They have to do everything on edge, and they just don't have consistent connection. Specialized autonomous teams, where you have a group of robots, each with its own skills, will be the best way to execute these edge missions, right? You have these general purpose robot builders, you have these drone platforms, and you have logistics managers, but no one is focused on making swarms of robots that have specialized specialization inside. Essentially, many different robots in this team working together. And this is the only way where you can have a team of robots work autonomously where you don't have human oversight. So we build collective intelligence at Veritech, essentially letting specialized teams self-direct themselves on the edge where there's no human direction or limited human direction. Operators prompt a mission, basically stating, hey, here are our goals, and the robots will self-coordinate, assign, and execute the mission in real time, adjusting to environmental factors. This is our OS layer that we want to try to work with different robots on. And over time, these robots get smarter, building their own learning curves, and the collective as a whole gets smarter. This drone in the corner here is our Falcon. We've built out our own drones. However, our software is agnostic with any industry and any robot. We've built out our own hardware, so we do have our own drone platform, like I mentioned. These drone platforms actually work together, so you have ground stations and drones working together in real time, but that isn't limited with drones, as said. So one of the key specializations of our software is understanding the components of every robot in a team. So in Falcon, for example, we have drones with different payloads on board. So you have drones with lidars, drones with thermal cameras, and drones that are built to be fast. And the software recognizes, hey, these are the specializations of each drone in that swarm, and how can we utilize each of these drones effectively. So over the past couple of months, we've done some pretty cool stuff. We've focused on how can we have many different robots that have different training sets and have different software or even physical capabilities agree on a certain thing. So, and then how can they auction off tasks to one another, basically so that they can have better specialization, better task allocation in a swarm. We currently are working with the US Army with a partnership with the Naval Research Laboratory, where the Army has asked us to produce a swarm of what we call our peregrine drone system for training. It's basically used for hostile drone simulation in training environments. In Ukraine and Russia, we see a lot of drones attacking infantry. And in the US, we're trying to develop systems so that our soldiers on the ground know what to do when a hostile drone or SUAS attacks them. We currently have a couple of conversations going on, some with the Coast Guard and some with the Army Research Laboratory. Right now, we're targeting the Army first, but some other things like Marine Corps in the works right now as well. These opportunities are pretty big, and so we're asking for capital to help support these pilots. Um, and down the road, of course, there's a lot of opportunity with Border Patrol, FEMA, Coast Guard, and even just the B2B private sector. Um, so like I said, we're building the OS, the coordinated autonomy platform. Although we build our own robots, we sort of see it as we will be in every single robot that wants to work together in the future. Um, with the planning, coordination, and safety nets that any team needs. Um, so today, it's a small team. We have a new SVP for Frontier Tech, and she's to be announced. She was the former director of AI for the DoD at the Pentagon. And then we have some researchers from NRL and some that are not pictured here as well. NRL, we have some from NASA as well that we haven't pictured here. A couple advisors from DoD and DHS, Undersecretary of Defense and Undersecretary of Homeland Security, among some others. So lastly, we're raising 3 million today for a seed to develop Army products, fund pilots, and scale the team so we can do more things in the future. Thank you so much.
Absolutely. Thank you, Michael. And just a reminder, I forgot to mention, ideally, if you could raise your hand on Zoom, that's great. Otherwise, you could just butt in and ask questions. The floor is open.
Can
I'll
I
give
go?
everyone a second to
Can I go first?
for it.
Is it okay? All
Yeah.
right, thanks. Yeah, that's great solution, great presentation, Michael. Just great. You're up to something really cool. I appreciate it. The just a couple of quick questions that I have some background in robotics, that's why I know. But could you tell me? It's just questioning about the some I guess limitations in especially robot swarm. How do you handle like a bandwidth saturation and also the signal vulnerability, such as like maybe I know you mentioned the wartime scenario. So like a battlefield, like there could be RF jamming or GPS spoofing. How do you handle those?
Yeah, so we have some models on board our robots we call network healing. Basically, when the signal gets weak, the swarm will reconfigure itself to strengthen the connection. So basically, it's with physical movement. With our current hardware, right, we can't control other people's hardware, but with our current hardware, we have software on board that includes signal band hopping and jamming software that allows us to have more resilience, but of course, jamming is always a problem, right? So we basically go on this approach of if our software and our hardware is jammed, then the swarm will try to reconfigure itself the best to reconnect itself, whether that's getting closer to another node in the mesh or even sometimes getting further away can help as well.
Right. Now, is your level, are you in POC level with you mentioned that U.S. Army research lab and things like that, how far are you into development and their usage?
Yeah, so with the US Army, I would say that so the contract that we're working on right now is production within 90 days. So it's production money. It's not research money. So that's kind of where we are there. We have conversations with the research and development folks at Army Research Labs, but our primary kind of use case here is how can we get something to the end user as fast as possible so that we can understand the needs of the end user and then try to develop for the needs instead of going the other way around.
Thank you. Great.
We have time for a few more questions if people want to ask.
Can I
Yeah,
jump
go
in?
for it. Yep.
Great presentation, Michael. Thank you. So how do you differentiate your software to compared to others? I mean, I've seen lots of autonomous, robot swarming, and the companies who build autonomous platforms, autonomous software for these kind of platforms. So I was just wondering how you differentiate from them.
Yeah, it's more that we focus a lot on the orchestration layer. What we've seen a lot with these swarm companies is like, it's very closed off to their products and it has to be kind of their hardware. We basically have some models on board that when placed on any other robot kind of understands the capabilities of that robot so that they can seamlessly be integrated in the swarm, right? We basically focus a lot on, okay, if you look at any large organization, they thrive on specialization. You have different departments, people focus on different things. And so we basically make the same layer for robots, right? We're like, if humans, if there's no generalist human in a company, right, there's a reason why you have departments. Why do robots need that as well? So we basically are we're basically a lot more open to working with different partners because we believe that we're not going to be specialists in hardware. These companies have had decades of experience with hardware design and software design. We're just connecting different robots from different companies together. Like, a classic example is NVIDIA and Qualcomm both have different robots. They have different training sets and different software. What if you could combine the brains of both of those robots seamlessly, pretty quickly? That's what we're focused on. It's less of the robot and software design. It's more of the connection layer, the communication coordination layer.
Sure. We have
And
time for one more
Michael,
question. Yeah,
yeah,
go for it.
Michael, I'm really curious when you start looking at the integration of that, have you started looking at where the platforms could loiter in order to provide that connectivity, and what is the range of the signal you could generate
Are you talking about our drones, the drone swarm we're working on right now?
from from the control mechanism of being able to interact between multiple sets? I'm curious from the coverage of how far that system could be apart from each other. And are you thinking in terms of, hey, I could put a larger drone higher up to disseminate the signal down between multiple drone sets and be able to carry that signal across that bridge? Have
Yes.
you thought through that?
Yeah, that is something that we've thought about right now. We've only tested out the signal. I think our radio is rated for 100 kilometers between nodes. We've tested it up to 10 kilometers. I'm not a very I'm not very big into specs because we know that those specs are done in ideal conditions. So we've only tested up to 10 kilometers in more contested environments. But yeah, the whole point of specialization is so you can have that bigger drone in the air disseminating that information, right? You have to have a swarm that understands, hey, there's a bigger drone with a better kind of radio. We can have that larger drone up higher. And so we're basically creating software for, okay, the smaller drones are under, the bigger drones on top, but they know to do that without, us sitting there and doing years of integration with two different companies, one that builds a bigger one, that builds a smaller one.
Have you thought about also putting a radar on that higher drone to be able to tell where the drone swarms actually are and how they're flying through the area?
We have not we any sensor suite that's placed on, at least for drones, we've proven this out in drones. If you take a larger drone from another company and you put it up there with the radar, that it can integrate into Swarm as the Swarm will get that information. If that's what you're asking, we haven't built out the hardware ourselves. Like I said, we're more kind of testing out our hardware as an embodiment and less so of a final product. I mean, it's sort of like we focus a lot more on the operating system layer.
Yeah, it's a leading question, I know. I am curious where we could take this from a Golden Dome perspective and being able to say, I understand what is under my control and what may be an adversary flying into the space, and how
We
could we react accordingly?
So we do have one of the products that we're working on that we haven't announced publicly is a counter UAS program, essentially where you have multiple drones coordinating among themselves on how to take down an enemy fleet of drones, whether that drones or ships. Oftentimes we are expecting our counter UAS swarm to be smaller, so it's like how can you use 5 drones to disrupt an enemy swarm of 20, right? And so you have Overwatch and all of those elements. It's very similar to how the military operates, but we want to use the robots as partners rather than, a
Yep.
burden on the operator.
Yeah, well, especially when you get into a very contested, dense cityscape, right?
Yeah.
The radio signal gets disrupted. You've got more interference. You're going to need more sensor nodes that can actually disseminate the signal across different
Right.
form factors, whether that's on the building or on a mobile or a higher Overwatch type drone, providing that connectivity. But I get where your headspace is at. Um, would love to be able to continue that conversation offline. Thanks.
Yeah, of course. Yeah, my email's in the chat if you want to just connect offline and keep chatting.
And Scott, do you want to quickly introduce yourself? I know that you joined recently. Yeah.
Yeah, I got in a little late, right? So,
Yeah.
Scott Heitman, I'm the DAF, Department of the Air Force CTO, and I've been working lately with A4 and A3, trying to drive some of the integration within the Department of Air Force. But for the most part, it's just about trying to drive innovation across the DAF and connect the right people together to have the conversation. So,
Hey,
appreciate
what's
the
a DAF?
opportunity to be on there. The DAF, Department of the Air Force, DAF.
Oh, okay.
That's
All
what
right. Gotcha.
that's the
Gotcha. All right.
acronym
Good.
we use.
Okay.
Yeah. Thank you
Okay.
so much for joining. Perfect. And Michael, I think that's it for now, and we'll make sure, Scott, we'll make sure to coordinate between the two of you guys.
Yeah.
Yeah, thank you so much for the presentation. Next up, we're having Codex Quantum. You guys feel free to start presenting whenever you're ready.
Hello, hello.
Hi.
Looks like my background blur isn't working. It just makes me a black screen, so I will go without it today. You'll see the mess behind me. Hi. Let me start sharing 1 second. One second.
If you need, we could also maybe share it on our end if need be.
I think uh I think I'm good. Give me 1 second. Okay, let's try this. This one too. Can you guys see presentation?
It's a black screen now.
Ooh, all
Still,
right.
still
Let's
black.
go with you sharing then,
Okay.
because I think
Brian, are you?
It's a Linux issue.
Oh, nice. I
That's what I was
I'm a
hoping that.
fan.
Yeah, fan when it works, right?
Yeah. Thank you, Brian.
All right. So I did change the slides slightly to suit the audience a little bit more, but let's go with how they are. Um, so, hello everyone. My name is Dr. Ethan Evans. I am the Chief Research Officer and co-founder of Codex Quantum. I have a PhD in aerospace engineering. Our CEO is an exited founder. Our team of PhD scientists come from Navy Research Labs. And what we build is quantum enhanced AI tools that accelerate the hardest computational problems in engineering. We're starting with CFD. So today I want to show you what that means across modern engineering disciplines. So the pace of modern engineering needs is just clearly outrunning our ability to create well-catered solutions. Design cycles that take weeks or months cannot support a rapidly changing operational landscape. This is not a talent problem, it's a compute problem. Classical simulation tools have hit a wall. It's a classically intractable problem space. They force teams to limit the scope of analysis, reduce fidelity, and test a narrow slice of the design space. The result? Suboptimal designs, longer timelines, higher risk carried into late program phases. That costs money, and in some cases, it costs lives. Meanwhile, quantum computing capabilities are scaling rapidly and open a fundamentally different approach to those bottlenecks. Next slide, please. So where it hurts most is CFD, computational fluid dynamics. Computational fluid dynamics is the backbone of system performance engineering. Every platform and every domain depends on it. Range, fuel efficiency, thermal management, noise signature, survivability. But the reality today is brutal. A single high fidelity CFD run can take 10 to 15 hours. Meshes regularly exceed 50 to 100 million cells with a clear desire for more. HPC queue times push the total turnaround time to weeks to months. The result is that engineering teams are forced to evaluate maybe a few dozen designs when they really need to evaluate thousands. That means critical design decisions, the ones that determine range, fuel burn, payload capacity, are made with incomplete information. Engineers are forced to rely on low fidelity proxies and narrow parameter sweeps, which pushes risks into later, more expensive program phases. This is the bottleneck we are targeting. Next slide, please. Here's what we actually do. Your engineering team keeps working on the tools they already use. They give us their CFD data, their meshes, their boundary conditions, their flow conditions, their geometry parameters. Our platform uses quantum-enhanced machine learning to compress the computational space and explore orders of magnitude more designs under the same compute budget. Instead of evaluating 30 designs over 2 weeks, teams can evaluate thousands in days. We're not asking anyone to replace their solver. We target the highest cost steps in the solver loop, the initial guesses, the parameter sweeps, the design space exploration. We accelerate those specific bottlenecks. The result is faster time to decision with higher confidence and higher performance on the same infrastructure teams you already have. Next slide, please. Let me put this in program terms. Today, teams are forced to pick a small number of designs and hope they pick the right ones. With Codex, they explore the full space and let the data tell them where the best solutions are. That means more performant designs with fewer surprises downstream, reducing uncertainty. Every percentage point of risk you can retire in the conceptual design saves orders of magnitude in cost during detailed design and testing. And we're not limited to a single physics domain either. Our approach supports aerothermal, aeroacoustic, aeropropulsion, and aerostructural analysis, which means teams can move toward holistic vehicle optimization instead of siloed trade studies. To put a number on it, in commercial aviation, a 1% improvement in fuel burn translates to billions of dollars in life cycle value. That same improvement also translates to range, endurance, payload capacity, and survivability. CFD experts suggest better design space exploration can yield a 10% improvement. That completely changes the set of possible missions. Next slide, please. The same capability applies across every domain where CFD is a bottleneck. On land, think about what it means to design a drone around a specific emergent need in days instead of months. In air, we're talking about reduced fuel burn, increasing maneuverability, optimizing thermal management, and for UAVs and this is for UAVs and next generation aircraft. At sea, submarine acoustic signatures are directly tied to CFD fidelity. Better cavitation simulation means quieter subs. And in space, the fundamental constraint is always payload capacity. Even small improvements in rocket nozzle or aeroshell design translate directly to much more payload capacity per launch. Next slide, please. So who are we? Our CEO, Stuart Pino, he has built and scaled a technology company to an exit before. He knows what it takes to go from prototype to product. I have deep expertise across aerospace, quantum machine learning, stochastic optimization. I'm the first named inventor on our core technology, and I'm always finding new ways to innovate. Our technical team are PhD scientists and engineers who came out of government research labs. We bring deep expertise across quantum, QML, aerospace, mathematics, and computer science. And that gives us the ability to attack this problem from many angles simultaneously. We have been working together for several years and have a growing portfolio of peer-reviewed publications. This is not a team that was just assembled for a pitch. We have been building toward this for a long time. We know how real systems are built, from engineering design concepts all the way through to test and evaluation and final delivery. Next slide. Again, we're not starting from zero. Our team members have direct experience with Sandia, OUSD awards, ONR awards, and IRAD grants. We have active relationships with RTX BBN, with NSWC PCD, which is the Navy lab we came out of. On the commercial side, we have been accepted into two of the most competitive deep tech accelerators in the world, Alchemist and Creative Destruction Lab, with cohort ties to the University of Toronto and University of Chicago. We have raised about $500,000 to date and are actively pursuing pilots to fuel our next round. Importantly, we're not just writing papers, we're tackling real problems with our models on real IBM quantum hardware. This is a level of technical maturity that most companies in the space have not reached. And I want to, yeah, next slide, thank you. So what we're looking for is two things really. First, design partners. We're looking to design our product around real problem needs, around real needs that are out there. If you have a CFD team that is running up against these sorts of bottlenecks that we described today, we want to run some sort of evaluation with them just to understand where they're experiencing the problem, how they're experiencing it, and how we can better suit what we're building to their specific use case. We bring the platform, your team brings the problem. At the end, we have a clear answer on whether this accelerates your workflow. We want to fine-tune our product around your pain point, including relevant flow conditions, other domain-specific considerations. Second, we want introductions. If you know a program sponsor that is investing in digital engineering, PEO, program officer, if they're investing in modeling and simulation, quantum algorithms, or HPC monetization, we would love an introduction. Those are programs where this capability really just lands naturally. As a small business, we're constantly looking for opportunities suited towards small businesses. We would love to expand collaborations as we seek SBIR/STTR funding once those programs are renewed. Next slide, please. So really to summarize, the pace of challenges is accelerating. The engineering tools we rely on have not kept up. Quantum enhanced computing changes that equation. We're building the tools that let your engineers explore more, decide faster, and design with higher confidence. That's how you maintain the engineering edge that underpins building world-class systems. I would love to talk with anyone in this room about how we can work together. Thank you.
Perfect. Thank you so much, Ethan. All right, opening up the floor. If you guys can find the raise hand button, feel free. If not, feel free to just jump in. All right, Marissa, go right ahead.
Hi, which quantum computer are you using to run your
So
simulation?
we currently work very closely with IBM. They're an investor actually. So we have a lot of IBM compute time, but we are not we're not just on one platform or another. We can deploy our solution on really any gate-based quantum platform. They're all building around a centralized set of tools and a centralized set of language. So we can deliver on any platform.
Okay, thank you.
Kathleen, go ahead.
Yeah, so great presentation and interesting concept. So if let me make sure I understand your offering. Within the realm of computational mathematics, you're looking at mapping out the broad landscape of where to optimize. And so once you work with a customer, are you saying, look in this valley, look at this peak, and then they go back and apply their tools, which take a lot more time? I mean, is that really
So we're really looking to accelerate their workflow through accelerating the tool itself. The computational fluid dynamics run has a lot of things that it's a classically intractable problem. And that means that if you want to double the density of points in your simulation, then your compute time is going to go up exponentially.
okay?
And so we're really trying to tackle that classical intractability with our tools. And so what that means is when we say better design space exploration, if you've shortened the time to solution on CFD runs, really what that opens the door is looking at many more designs, and really that is a critical flaw in the way that things are done today because you can really only look at this narrow slice, and so you hope that you've picked a good region of the design space to start with.
Okay. Because you have to dumb down the problem to make it
Yeah,
solvable. Okay.
exactly.
Because where my mind is going with this is so CFD, I get that actually I used to work for the nuclear Navy design agency, so I know about impeller designs or propeller designs. But the other element is in with the chemical discovery, right? So we have high throughput landscapes, and the question always is, are you looking in the right area to
Yeah,
target a high throughput tool? So there may be some analogs here that could be of use in this industry.
that's awesome. Thank you.
Yeah, and there's one question in the chat that I'll quickly cover is someone asked if you'll be joining JTC3 for quantum standardization. I'm not sure if I'm so familiar with that, but maybe you are.
Um, it sounds like something that I should be familiar with. I think that it is not on our radar as of this moment, but we will definitely be looking into it. And if it's something that seems like it's something that we should attend, then we'll definitely make our best effort to be there.
Cool. Awesome. All right. I think that's what we have the time for. But if you want to leave your email,
Sure.
yeah, in the chat, feel free, and I'm sure some folks will reach out and shed some light onto, some of those letters there. Um, Perfect.
Thanks, everyone. Thank you for your time.
Absolutely. Next up, we have Edlore. Feel free to start sharing whenever you are ready.
Please let me know when you see my screen.
Sure, it's loading. All right, we can see it now.
Awesome. Thank you very much. My name is Javid Vahid. I am a founder and president of Edlore. Edlore is a software platform essentially to help maintainers, people that actually have tools in their hands to do their service and repair jobs as safely and as efficiently as possible. Edlore is actually was formed out of necessity. I'm a robotics engineer, and I have been in my previous company. We used to service a lot of instrumentation, and every time we were looking for documents and we couldn't find them. So we used to scan the documents into a memory stick and attach them to every instrument that we put in the field, and so that we could at least have access to the documentation. The more that we use this device, we realize that, okay, that's good. We can see the PDF, but we see the world in 3D. Why can't we have our products converted into an interactive 3D? I mean, the instruments that we are trying to fix. And I don't know why this is not going to the next page. Oh, that's it. So unplanned downtime is expensive. There are a lot of a lack of maintenance is the main cause of downtime of machines, and labor shortage due to skilled labor. The generation that know the systems are all retiring and going. Instead of following the actual presentation, I want to show you the product. What we are doing currently with the NAVC and the DoD, as you can see on the screen, you normally work off of these kind of drawings to service a component. Very cumbersome, and you got to go and figure out what part numbers are and so on. So what our system does, it takes that same drawing and converts it to what you see on the screen here. Now I can actually explode this to its internal components, be able to click on any part, be able to get part number, be able to get the NSN number for DoD, or any information that they can put here. Now I can actually start creating a pick list of what I want and put it in a shopping cart. And now I already immediately have a purchase order already done. And if I have connectivity to the systems, like for example in the Air Force, FEMS or IATMs or any other systems, DoD or non-DoD, SAP or otherwise, it will automatically place the order, and it actually sees if it has the part in the inventory. The one other thing that I want to show you is our glass wearable service and product, where if I have tools in my hand, I can wear these wearables, and then I still need to have access to the documentation. I can give it verbal commands. For example, this is a winch for NAFC. I can say explode. As you can see, rotate right. Show me reset. Show me where the support compensator is. Show me pillow block. Deselect. Camera. So as you can see now, I can augment this on the actual reality. Now, a perfect use case for training would be if this is, I'm an instructor and this is my hand. I'm standing in front of a device and you're all students that have signed into this training class, right? Now, I cannot open up the winch actually, but with the 3D here, I can actually explode this to its internal components and show you all how this thing is done. So this could be the closest you can get to a hands-on training without actually being present there. So that's another use case for the glasses. If I can go back to the presentation. There's a lot more. I mean, there's the AI aspect to this where you can, every information that you're gathering from the field, you can actually becomes part of the historical data on how that particular component was maintained or serviced. And all of that now become information that can be fed into the AI, and AI can actually answer query in austere situation, air gapped, which we are working with the Air Force at Warner Robins at the moment. I'm going to skip because since I showed you the actual tool, there is a lot more. There's work order management systems, remote expert video chat, everything is there. As I said, we are TRL 7 or 8. Asset intensive teams with complex technical data. Again, I'm going to bypass all of these because I showed you the system. The business model is platform subscription, onboarding, and SaaS, go-to-market plan. We are actually, as I said, we are in DoD. As you can see, this system is not necessarily just for DoD. We want to break into non-DoD, and it could be used in manufacturing, could be used every system that's out there, drones, everything else. You still need to maintain them, even with the AI. And our system can get plugged in to any software device to help with the documentation, with the information, with the maintenance. I'm going to bypass these. I showed you the glass, so I'm going to bypass this as well. Our leadership, as I said, I'm the president. We've got the very good engineers on the 3D engineering and also database management. We've got ex-DoD and DOW SMEs that are on board with us. Ex-colonels that are helping us to expand in the DoD. Eagle Point funding is a great help that we are working with. We are finishing a phase 2. We are starting a non-cyber with a program with the Marine Corps. We are starting we're in the works with the NSWC 5-year contract. Again, with AFMC, we have a sponsorship for phase 3. We are already working with the NAFC and the Eagle Point. Now, our ask is to raise $5 million to actually expand into the non-DoD, because non-DoD is a whole different world that we need to really start concentrating on. And there is also a possibility of procuring that from the manufacturer of this glass, and we are hoping that we could, as an option, could raise money to be able to purchase this and all the inventory, the IP, and also the manufacturing for these glasses too, because we have a lot of use cases for these glasses.
Sure.
I think with that, again, as I said, the projects NAVSEA, ONR that we have finished already, and EDLOR supports robotics and future automation, and so on. Okay, I will stop there.
Perfect. So there's a few questions from Scott in the chat. Scott, do you want to ask them, or should I ask them? I could ask them if you would like.
Happy to do it. So, love the presentation, Javid, and
thank you.
I really encourage you to keep looking at the non-proprietary, right? Driving to a central standard. At the end of the day, I don't know whether the Air Force is going to land on an Apple Vision Pro or a Google device. But maintainers, whether it's inside the aircraft maintenance or vehicle maintenance, or with civil engineering looking at a motor or a part, we want to be able to drive that conversation and getting the visual, that VR visual over the top of the real live item is critical. And part identification, is it this motor or is it this motor? And they break down differently, right? So parts are different. We want to make sure that we've got that. So driving to a central standard, and forcing the VR industry to make that cross-platform agnostic is kind of where the DoD has been driving, where the DAF is certainly interested in it. We'd love to know how far you are on looking at that cross-platform availability, and then how well is the AI getting after the part identification?
Right.
Like once you've got it loaded in the database, could you determine, engine X versus engine Y?
Definitely, we are already doing that, Scott. Obviously in 5 minutes there isn't enough time to show everything that's going on right now. But I would be very glad and would like to spend some more time and show you all the other aspects, all the other features that I did not even discuss with you, and actually show how the AI works. One thing that is really interesting, the Marine Corps are interested, is the air-gapped server that we're building, that they could put all their documentation in and put it on the ULVs or the JLTVs, so that these servers we are actually making them small enough. NVIDIA is coming up with new hardware that we could make this small enough so we could mount them on these ground vehicles, and they would have access to all the AI capabilities in austere situations.
Awesome.
Yes, sir, Mr. Cole.
Yeah. Question that I have is that you have it's a good presentation and you have a good product there. Appreciate it. Now, could you tell me what kind of unfair advantage you have? This is a market with some competition. So I know I happen to know a company called like AR Genie and Data Mesh. Especially Data Mesh using like digital twin. So how is your product different from theirs? Could you elaborate that a little bit, please?
Yeah, very good question. Number one, we have a patent, U.S. patent. It's a utility patent on the software. Number two, we have a platform that is not just digital twins. It's got remote expert video chat. It's got work order management system. It's a platform that covers a lot of different aspects that are some companies concentrate on the creation of 3D. Some concentrate on the remote expert video chat, but ours has everything built in, and it's basically a plug that they can plug into any software that would start monitoring and be able to do everything that I mentioned. So these are the differentiators. And also, a lot of these companies require CAD to convert into the 3D. We don't. What I showed you on the screen, which was that the exploded view on a 2D, all we need is basically that. If they have the CAD, obviously it's much easier, much better. But all we need is the CAD, and what I showed you, the exploded view was from a written 2D on paper that we converted to 3D. And we have a combination of AI and human intervention to clean that up. And we have built this. It's very fast, so it's really scalable as far as expansion.
Thank you.
Cool. And then there's some questions in the chat. I would recommend that you reach out to them. And thank you so much for the presentation. And yeah, there's definitely some interest there, it looks like. So feel free to reach out to me if you need anyone specific. I'm happy to help make the connection.
Yes,
Thank you
thank
again,
you.
Jimmy. Yep. Next up, we have Haptag AI.
Yeah. Let me share my screen. All right. Can everyone see?
Yep.
Perfect.
Now we see presenter mode.
Oh,
Before we had it regular. I don't know if you're able to.
or Asher, do you mind sharing the slide?
Okay. Yeah, just give me a second. Yeah, here we go.
Perfect. Hi, everyone. My name is Sarah, and I'm the operations manager at Haptech AI. Originally, our CEO, Andre Kreho, was scheduled to present today, but unfortunately, his flight got delayed. So I'm here to step in today and show you how we're turning millions of event log into actions. We are Haptech AI. We provide AI-powered anomaly decision making and automation decision making based on your preferences. Haptech AI is an next slide, yes. Haptech AI is an AI-powered log anomaly intelligence platform built for event log analysis and anomaly detection, specialized in advanced persistent threats and insider attacks. The platform empowers cybersecurity and other analysis to spot both point and sequential anomalies. We can work with any signal intelligence data from logs, cell phones to cyber warfare signals. The future of cyber defense is AI to AI, not just human. Next slide, please. So right now, the current tools have these four main pain points that we have identified. First thing is they're reactive. Most tools act like fire alarms. They initiating remediation only after a failure occurs. The second thing is the logs are massive, so human cannot possibly review billions of massive logs every day, that leaving the dangerous threats hidden. The third thing is the tactics are now evolving because hackers are using AI to change their attacks every second, faster than any human can track. Lastly, all defenses are looking for yesterday's trick using an unstructured approach. We need explainable detection that shortens the triage. Next slide, please. So on the previous slides, I've showed 4 ways the current tools are failing. The adversaries are using AI to perform the attacks, and your only option to fight back is use AI. So here's exactly how Haptech AI fix each of them. So to fix the reactive defenses, we use predictive learning. We don't just wait for the breach, we learn the patterns and stop the attacks before it executes. Second things, to handle the massive log noise, we apply multi-layer detections, which filters out billions of normal events and pinpoints the actual multi-step attacks, and also practically eliminating false positives. The third thing is, since the adversaries are using evolving AI tactics, we fight back using autonomous remediation. We also fix the unstructured approach by building an expert knowledge base. We've encoded decades of forensic reasonings into the AI. So the AI, Haptech AI just not block the threats, but also explain the why behind it. We have a unified multi-layer detection approach. We identify point and sequential anomalies while drastically reducing false positives. Next slide, please. Most importantly, we do not force you to replace your current systems. Haptech AI is a black box solutions that augments on your current SIM solutions. We sit on top of your SIM detection, ingest the data, process it through our AI triage and semantic cache, execute block and tackle actions via autonomous agents based on your preferences. We can process all signal intelligence or filter selected types. We built a strong AI multi-layer detection based on encoding, decoding, and zooming with the latest models. We have developed our own data modeling with embedding and tokenization with expertly trained on-site deployed small language model that's both affordable and fast. Next slide, please. So our go-to-market strategies address a massive dual use opportunity. We are not just targeting the analysis and detection market, but also the remediation and automation market. The total addressable market for us is around 3.23 billion. Next slide, please. Haptech AI is built by a team that understands both math and the mission. Our CEO, Andre Kreho, holds a PhD in digital choice and forensic investigations and have spent 30 years responding to frontline compromises. He has one previous successful exit backed by Sequoia, Google, and CD Ventures. He knows exactly what the forensic patterns look like and what the current tool miss. Our team also include deep learning and LLM PhDs and masters from Columbia University and University of Southern California. Next slide, please. Our ask today is twofold. For the investors in the room, we are raising a pre-seed round about 1 million, and this capital will allow us to scale our tested prototype to the broader enterprise market. For our DOW partners, we are looking to connect across Army, Air Force, and Navy. We want to deploy this as a pilot, co-design use cases with your operators, and prove our value in your live network environment, and to help the current AI capabilities in US government. Next slide, please. Thank you so much for listening. Feel free to reach out, and I will leave our CEO's contact in the chat, and happy to schedule a meeting or a demo session. That's all.
Yeah. Perfect. Thank you so much. All right, opening up the floor for questions. You want to, Sarah, would you mind going deeper into some use cases?
Yeah, so in our use cases, we will the we targeting mid-size to larger companies. We're already deployed the same detection platform because current SIEM platforms, we believe it only capture maybe 70% of the total anomalies, and it's also reactive. But we are trying to augment the 10%, 10 to 15% of the most dangerous attacks, which are the insider threats and the APT attacks.
Sure. And so, like, in terms of like malicious events or anomalies, like like, for example, let's say DOW, because I know there's some folks from the DOW on the call, but like, what kind of situation would that be per se? If anyone else has a question, feel free to jump in. You don't have to. Yeah, go ahead, Sarah. Sorry.
Yeah, so it's the same. So for DOW, it will be so more like if someone originally have this access, but it's um, like copying or using the material that this person not usually working with. And from us, we are able to capture that from the early stage before the incident actually happened.
Cool.
And we've tested three simulated insider threat scenarios. We've tested on Sentinel-1 and Microsoft Sentinels, and both platforms missed the simulated attacks, but Haptag AI is able to capture that. And we're looking forward to testing that on the real industry data.
Sure. That makes perfect sense. Thank you. Thank you so much, Sarah, for the presentation, and feel free to leave your email in the chat.
Yep.
And yeah, folks
Thank you,
will.
Usher. Thank you, everyone, for listening.
Absolutely. Next up, we have Helios. Jose, the floor is yours.
All right. Good to see you guys. Can everyone see the screen?
Yep.
Great. Well, at Helios, we are, best way to look at it is we're solving the energy bottleneck problem that exists with AI. Everyone's heard, at some level or another, this problem that's going on of data centers are eating up too much energy, of AI companies, then they're capped by their access to compute, right? Data centers can't build as fast as AI companies can scale their software and users. And so what you have is everyone is at the very end of the day bottlenecked by access to energy or energy production. So what we're doing is we're turning stranded energy throughout the power grid, and it turns out there's a lot of it. And this stranded energy you can look at as underutilized capacity on the grid into AI compute. So we're a cloud company, and the way we do it are through these modular data centers. Now, I'll explain our process, but through our process, we're able to provide compute to AI companies. This means when a company like OpenAI needs to train a model, or every time we use ChatGPT, the computing necessary behind that, that's what we provide. So we're able to provide it at a third of the cost of AWS, for example, or Google Cloud. And we do this by deploying these modular data centers near underutilized power sources. And in the last couple months, we've done about 1.5 million in revenue. So the way it works is the demand has been doubling every 100 days, right? So the demand for compute is far outpacing the rate of infrastructure growth. And we're aiming to solve that problem. We do it using this modular data center. It's 40 by 20 feet. And we're able to put in about 1,000 GPUs in this. And these GPUs will ultimately produce a revenue. They're rented out through our cloud platform to these AI companies. We use a combination of immersion and closed loop liquid cooling. And what this means is that we don't need any water for our data centers. You might have heard about how much water it takes to cool down these data centers. Ours recycles the same exact water. That means we can plug these in into more spots. We just need a source of power and we're good to go. And it's power agnostic. We can plug into geothermal, natural gas, hydro, whatever it is. And we can do this very fast. We can deploy tens of these in just 4 months. So what we built, and this is where our secret sauce lies and where our moat lies. What we built is this platform that allows us to map out every single power plant in the United States, as well as fiber infrastructure. Those are the two things we need for a data center. We need power and we need fiber. And then we look at all the power plants that are underproducing. In other words, ones that are operating at 40 or 50% capacity. See, the real problem isn't that there's not enough energy production going on. It's that there's not enough energy transmission. It's that all these power plants are underutilized and they can't get enough power to the particular places that data centers are asking for. So what we do is we just bring the data center to the power and we station up these modular data centers right next to these underutilized power plants. The way it works is we call it the power plants. It could be a geothermal plant that's operating at half capacity. And we say, you guys would love to be selling more power, but you're capped by how many customers are in your immediate geographical area and the limited transmission infrastructure. So how about we reserve X amount of megawatts, let's say 20 megawatts of power, which is enough for about 15 of our modules, and we'll reserve it for the next 15 years. So they end up giving us very, very cheap power for the next 15 years, and we get to put up a data center immediately. Most data centers are facing 3 to 5 year long wait times just to get connected to electricity, which of course holds up their customers and the whole process and makes it all more expensive. So we get to bypass all of this by going straight to the power plant. And we've been able to line up these contracts because of this tool that we built. Not everyone has access to this kind of information. And then ultimately we sell it on our platform, right? Our own cloud platform. And AI companies come in, they can get waitlisted or they can start using the compute immediately. And this is where our 1.5 million in revenue has come from in the last 2 months. So we have an energy producer, we put in our modular data centers, we rent out to AI companies, and we share some of that revenue with the energy producer. So they're very motivated to work with us. The market opportunity is massive. You guys probably know this. It's predicted over the next 5 years, about a $5 trillion investment is needed just for AI data centers. Now, the market opportunity, you might ask, in this limited selection of power plants that have enough excess capacity, that are already near fiber, that are available and are willing to do a deal with you, how much power is actually available and what can you actually do with that? But just in the US, if we were to convert all the excess power, which is about 12 gigawatts, into compute, it would be about $340 billion a year reoccurring. And that's all while being a third of the cost of AWS. So the opportunity is massive, and we're already talking to folks in Kazakhstan and Dubai about doing some there. So our progress so far, we have thousands of GPUs on our wait list. In other words, companies that say we need X amount of GPUs, we'll pay you for them. We have signed LOIs and over 100 million in the pipeline. And our first data center is up and running here in Salt Lake City, where we're based out of. And then where we're going, we have the manufacturing capacity to do over 80 megawatts this year. And we've partnered with energy infrastructure funds. So building these is not cheap. And the way we get around that is we partner with these big funds that are accustomed to funding data centers or solar farms, things like that. And they've been looking for projects to invest in. All the data center projects they look at are 3 years out. So what we do is we come to them with power and a lease on the land already reserved. And we're able to build within a few months. So they love to fund us. They're funding all our projects, and we just simply do a revenue share. They cover all the CapEx of the data center, the GPUs, and we get to take about 60% of the revenue from day one, and we're cash flow positive from day one. So here's our raise. We're using it for acquiring more sites, expanding the team, etc. Right now, we're a small 4-person team. There's myself. My background is in the energy industry. For years, I worked there, started a solar farm company, also managed a hedge fund. and worked in building out drones for Ukraine. And then there's Caston. He's our head of hardware, 10 plus years, mechanical, electrical engineer, working in the data center and energy storage industry. And our two folks on software at Mullen Street. And they built out cloud platforms before. So they're covering the software side of things. And that's us.
Cool. Awesome. Thank you so much, Jose. Feel free to open the floor to questions. Whoever wants to go first could either raise their hand or just blurt it out. We're open. Sure, Michael, go ahead.
Yeah, Jose, great. Attacking a real problem that we see every single day. So from your perspective, kind of from the cloud, the buying and selling effectively of energy, do you view yourself as a marketplace that you're doing that and you're, let's say, regulating or selling um, energy prices and fluctuate demand, or how do you view kind of that business model?
Yeah. Well, I'll speak on the macro first, which is we're looking to be full stack, right? Many cloud companies are just doing the cloud platform. We're the cloud platform, the data center, and acquiring the power. But what we really take charge of is acquiring this power through contracts and selling the compute on the other end to AI companies. What happens in the middle, the manufacturing, deployment, etc., we outsource all of that, so it's easier to do as a small team. And we look at ourselves as supplying compute to the marketplace. So you could look at us as a marketplace, but we also work with other marketplaces. So I always use this comparison of Airbnb. If you have 10 properties and you want to rent them out, the easiest way to do it is you go through the existing marketplace that already has demand. So there are marketplaces like this for cloud, and we're able to supply the compute, and they just take a 18 to 20% cut. So we do that, and we also sell through our own platform.
Got it. And then just a quick follow-up on the hardware itself. Have you customized the hardware, or are you effectively just building modular structures that, anyone could if they had a use for?
We are the module itself is all custom. That was designed primarily by Caston, our hardware guy. And it has some cooling we have, but I'll be frank with you. The real innovation is not in our module, right? Someone could go about doing something similar to this. We think our system is very efficient, it's good, it's well priced, etc. But the real innovation is in how we've been able to source power. And the modules will change over time. The chipsets will change over time. We partner with AMD and NVIDIA and Supermicro and all these guys. But the one constant is the need for energy and access to compute.
Thank you.
Felicity, you want to ask your question?
Yeah, thank you. This great presentation, super exciting. I think you answered my question in a way, so working with AMD and you mentioned the others, are there other relationships, technology company-wise or channel partner and anything that you guys are seeking? I see that you're doing a SF New York tour and looking, is it pre-seed or seed? But other than the monetary side of things, are there other relationships or partnerships that you're looking at or tech stacks that you're trying to integrate, that kind of thing? Over.
Yeah, so there's something really cool happening in the industry right now where it's been dominated by NVIDIA with AMD as a side character. And everybody loves these NVIDIA chips because they're very effective, but everyone's built all their software on top of the NVIDIA ecosystem, on top of their software. And so everyone's kind of plugged into it. Now, what's happening is all these companies are coming out with inference specific chips, with chips that are really good at doing this AI compute and a lot cheaper and use less energy. And we're happy to work with them and plug those in. So we're always looking for new chip partners and willing to test those out on our platform and stay competitive. And we're also looking for energy partners. So there are folks who, aside from us going directly to power plants, there are folks who are doing microgrids, island grids, modular nuclear. There's a million modular energy production companies out there. We love to partner with all of them as long as the economics make sense.
Great, thank you. My email's in the chat if you want to reach out, but this is fantastic.
Cool. Awesome. Thank you so much, Jose, for the presentation. And yeah, make sure to connect with the folks that you should connect with. Next up, we're gonna have Nexogen, and I think
Hello.
yeah, howdy, welcome. Feel free to start sharing whenever you're ready.
All right. Hi, I'm Scott Phillips. I'm the somewhat self-styled vice nerd at Nexogen. Just to give a little bit of a background about us as a company, we're not the typical startup. We've been around for 23-ish years at this point. We're 100% US based. We're born here, raised here. We're not going anywhere. We don't do any kind of outsourcing. We service about 2,000 clients in the IT space, everywhere from four-person startups and nonprofits up to major construction companies you've all heard of. And yeah, based out of Nexogen, we've spun out about 15 organizations, driving a total now of like 100 million in ARR. What we're really trying to do is not just be an IT company, but also as we're partnering in the AI space with key labs like the University of Cincinnati AI Bio Lab with Dr. Kelly Cohen, who, if anyone is from AFRL, you probably know him. And with the intended and purpose of taking that theory and research and turning it into deployable systems, specifically as it relates to explainable AI, because in the IT space, and we started with this in the phishing world, where we need to have the ability to identify spurious messages and things like that, but it's a more general problem than just phishing emails. It's how do you deal with intrusion and misuse in other areas like IoT and embedded systems? And one of the questions that comes up is how do you find that and identify it with tooling and models that are small enough to be deployed at the edge inside of resource constrained environments, inside of legacy systems, inside of all kinds of other air gap networks and whatnot. And one of the things that we also want to really believe in is that black box models erode trust because you don't know why the model flagged what it flagged. Our approach is different using what's called fuzzy systems. That is the ability to have these if then rules and a bunch of other stuff that I'm going to kind of gloss over here is we can give you a model that solves that problem, that identifies this thing, but then more importantly tells you exactly why it thought it was important and exactly why it would say it's not important. And as a result, we have the ability to, if the model for whatever reason is misbehaving, we can go in and surgically change it in such a way to say, okay, now that we know about this new capability or this new issue, we can make sure the model will always flag this again or never spuriously flag this other thing again. And we've been working a lot with benchmark data sets and both phishing and now in IoT. In the phishing world, we've achieved state of the art. We're at well over 99% accuracy with a model that you can train in about 8 minutes on a decent laptop and will do inference. And I want to say it's 200. John, our CEO, John, is sitting just to my right.
Yeah.
It's what, about 200,000?
278,000 emails. We can detect around 78,000 links, 28,000 of them being malicious in under.
It's like 6 or 7 seconds once it's trained.
Yeah, something like a couple seconds to make that distinguishment, which would be at expert human capability sets.
And as we're expanding that, this approach is not just specific to phishing. That's why we're here. Is like it's applicable to IoT. It's applicable to a host of other environments, and want to work in those spaces and partner with people in these spaces. We've started work on some IoT-based benchmarks, and we're hitting about 90% accuracy. We still have more to go, but this is just the initial work. The important thing to understand about that is these models take, minutes to train on a standard computer, and inference takes seconds. We don't require GPUs. All of this is done on CPU, and then the final train model can actually be offloaded to even smaller and more edge deployable hardware than just your typical PC. We're still looking, jumping up ahead a little bit, we're still looking for that initial breakthrough. We see, as outsiders, but familiar with the IT and security space, lots of places where we think this could be applicable. Zero trust sensors and enclaves and other legacy systems, but also importantly, human in the loop systems where we want to support your SOC analysts and your cyber people who are monitoring these alerts, make sure that they're always kept in the loop. They know what's going on. They're not in the dark. And also just in the case of deception or in contested monitoring, like we want to give you the rationale behind why we alerted or flagged something as potentially hazardous or malicious. Right now, we have a research collaboration with the University of Cincinnati AI Bio Lab. We've been participating in Deep Tech Showcase stuff with Eagle Point now for about a year and a half. But the key thing is we're still looking for that first breakthrough. We've had a lot of initial conversations.
In the government space.
Yes, specifically, we're still looking for that first breakthrough in government. We have a lot of success in the private sector, but we want to grow and also be able to help the nation. And so our primary ask is we want to get beyond that initial conversation. We want to talk to people and learn what your problems are and figure out ways that we can help you, whether it's with this or with other areas, because we have a number of other enterprise AI use cases that we think are applicable. We'd be happy to discuss those right now or, at a follow-up meeting. We're open to doing direct contracting, SIBR, sitter, we're eligible for both of those, whatever would make it easiest for you. And so I want to give our contact info real quick. I will also be posting that in the chat. So John Salisbury, our CEO, is sitting
Hey, how are you?
right here. I'm Scott Phillips. Jay Downs, our government account manager, I don't think is on the call. And then our website's there. And thank you and open to questions.
Yep. So whoever has a question, feel free to either jump in or feel free to raise your hand and we'll get to you in the order of which your hand is raised. All right, I have some questions then. Scott, you want to talk to us a little bit? I know in terms of the government, you said you were still looking for some use cases, which makes a lot of sense. Can you talk about some commercial use cases to pique some of the folks' interest?
Yeah, I'll jump in. My name's John Salisbury. We have some that are we had a sort of a marketplace of activities that were occurring in a larger organization. They had around 10 humans that were trying to keep track of a multi-layered marketplace where they weren't in control of the pricing. So it was a pretty advanced marketplace. Pricing costs would adjust without their control, and they would get upside down. And they had this their humans were not able to keep up with the volume and change in activities. So with them, we're able to automate that decision making with high precision to enable them to capture around 50 million annual in losses that they'll be able to capture through just alerting their people to take action. So that was through that we went to the customer, we gathered their data set, we created a model on it, we used their expertise to create the rule structures, and then from the same investigation techniques that they would use, we just made that an automated function. And then from there, we're able to alert them when one of these challenges that they usually would miss for up to 2 years, and they were operating at a $50 million loss anticipated in that space. That was one area we applied it to. We have another place where we did sampling using another technology, RAG, for people that were creating financial models around 100 pages. They had 5,000 like golden images, I would say, of known quality of samples. We were able to leverage that so that we were able to reduce their or help them reduce their document creation from a 6-month process to a matter of weeks with human in the loop process. We've had additional on adversarial detection and response techniques, such as the ones that we discussed with you guys. We've also had a bunch of data transformation exercises and automation projects that we've done in manufacturing and supply chain work.
Sure. And then Dylan, go right ahead. You're
Hi.
muted. Yeah, there you go.
Yeah, thank you. Very impressive. I guess I have some very fundamental questions. You already in the business for more than 20 years and have more than 2,000 clients, and you mentioned a couple of times you're looking for the breakthrough moment. What kind of breakthrough you were thinking?
So that's a slight miss. We were breaking through multiple places. We've had tons of organizations and spinoffs out of our group. We have 15 organizations. It's specifically in government. So in military, we started a
I
research
see.
lab, and we're trying to break through into government supply chain work or become a vendor where the government would work with. But no, we're having tremendous amount of success and
I misspoke. My apologies.
yeah, tremendous amount of success
No worries.
in commercial enterprise.
I understand now. I heard that you were adding that comment right in government, right? That makes sense
Yes.
to me now.
Yes.
Yep.
Yeah.
Then question on the tech side. Your model sounds quite impressive, training in minutes without using GPUs. Are you still using deep learning-based model or using different technology?
So I'm going to give a little more detail. We use what's called fuzzy systems, fuzzy logic. So it allows you to express, truth to a matter of degree. You create these if-then rules like if A, then B, or if A and B and C, then D, and so on. And it allows you to adapt, be a little more, flexible or fuzzy, pardon the pun, in terms of like how rigid you have to be with your rules. There are some very strong aerospace guarantee, mathematical guarantees. It is being used in the aerospace world. Thales Avionics, for instance, does use it. Um, it's another approach, somewhat similar to deep learning, but way more explainable.
I see. IP wise, do you own the I what's your partnership with UC impact on this IP ownership?
We have an agreement with UC where we have a shared IP arrangement, and we do different projects. Some we're creating IP in-house, some we're doing shared IP, and then sometimes we're using IP that they already have. So we're trying to be collaborative.
Okay, thank you.
Felicity, you could go ahead. Last question though.
Okay, great. Thank you. It's more of a comment, but it's really neat stuff. My point I was going to say is, or my brain stopped working. Have you looked at whether your competitors have any install base in the public sector, or any of your go-to-market partners or integration partners have a install base? Because I can tell you that from my perspective, my company, or the only thing we do is help people sell to the government. So if you were to come to me and say, hey, I want to break into the government, I would have a million ideas for you on how to do that. But it's typically when it's a company that has no install base currently, we typically we would ask, well, who are you partnered with? As I said, in the go-to-market, in the integration of tech. And then we would start from there because it's easier when you have that sort of like, I guess it's not really proof of concept, but at least a proof of partnership. Does that make sense?
It totally makes sense. And it depends on use cases. So sometimes we're bringing in groups that are already deployed. And I could just start naming names of people you've probably heard, and maybe some that you haven't that are doing deployments in the government space. That we're partners with and will leverage their technology. I wouldn't say we're just we want to be myopic in our approach, but in the genetic fuzzy space, specifically on the adversarial solution, we believe that would enable legacy systems to have highly intelligent functionality. And a lot of times limited to uh, they're limited based on the technology that existed for them, and some of these newer capability sets are now available in lower compute. So the install base for the genetic fuzzy model that we're talking about is not large.
Right.
But some of our other use cases will incorporate hybrid AI approaches and some other technologies like you're talking about that have larger install bases.
Interesting. Well, feel free to reach out. You can explore this over a, one-to-one VTC if that makes more sense.
That'd be fantastic. Thank you so much.
Great. Cheers.
Perfect. That's all the time we have. Thank you so much, Scott and John. Yeah,
Thank
sounds
you.
like you have some homework follow-up. So enjoy that, and yeah, feel free to leave your contact information.
Just drop it in the chat.
Perfect. All right, so that ends session one. Now we're moving to session two. We are going to quickly, emphasis on quickly, and I hope I can pull this off, quickly run through the panel, and everyone can quickly introduce themselves, and then keep it to 15 to 30 seconds each, because we're running a little bit late, as people could probably tell. But I'm just going to quickly call out names, and hopefully you guys can quickly introduce yourselves. Ben Patterson, you want to go first?
Sure thing. I'm Ben Patterson. I am with 10VC, which is a generalist pre-seed focused fund, checks from 250 to $1.5 million. And then I also am a partner for Elementum Ventures, which is also pre-seed focused, checks from 250 to $1.5 million, but strictly deep tech, a lot more sort of hard science, differentiated IP oriented investments there.
Awesome. It's a pleasure to have you. Next up, Rachel Marone. I don't know if Rachel's able to unmute. In the meantime, we can continue onward. Hyendo, you want to quickly say hello?
Sure. Hi, everyone. I'm Hendo from Honda Accelerator Ventures. We're a CVC for Honda Motors, focusing on sustainability, robotics, manufacturing, and mobility. We typically write 1 to 5 to companies from Series A to Series B, and looking forward to learn more about your business. And thanks for having me.
Pleasure to have you. Kevin Batty.
Yeah, hi, I'm Kayvon from Mighty Capital. We invest in B2B tech at Series A or earlier. Typical check is 3 to 5 million. and we connect our portfolio companies with a network of over 500,000 PMs and CPOs to accelerate your go-to-market. Nice to meet you all.
Pleasure to have you. Next up, we have Marissa.
Okay, I'm Marisa Alma McGinnis, and I'm interested in defense, AI, and longevity.
It's a pleasure to have you, Marissa.
Thank you.
Next up, we have Bahaya.
Hi everyone, Bahara Desai, Technology Scouting Director for BAE Systems.
Nice. Pleasure to have you. Dylan, you want to quickly introduce yourself?
Dylan Shen from Cincinnati Insurance. I'm mostly interested in AI data technology.
Pleasure to have you. Next up, Kathleen.
Hi, Kathleen German. I'm with Dow Corporate Ventures, major producer of chemicals materials. I'm interested in AI as it applies to discovery around chemistry and
Pleasure to
also
have you.
manufacturing, advanced manufacturing.
Awesome. Pleasure to have you. Rachel, do you want to quickly introduce yourself? Yeah, I asked for you to unmute quickly just to say hello to everyone, if that's okay.
Hi, I'm Rachel Marin. I'm at Dover Air Force Base. I'm in the Air Force innovation realm. I work with a lot of different software initiatives for A1, and I help them with their pipeline for making this an official Air Force or Space Force process. So, yeah.
Pleasure to have you. Thank you. Lindsay, you want to go next?
Yeah, hi, Lindsay Aspergren. I'm a partner with NTT VC. We're a $500 million fund doing early stage investing, primarily in the US. AI themed services, data, and agentics.
Perfect. Pleasure to have you. Han, you want to go next?
Sure. Han Ko here, USACO Group. I'm the president and CEO. We're a venture fund, and we have a strong interest in AI, deep tech, and IoT, along with other innovation. And so it's always such a pleasure to be here. Thank you so much.
It's always a pleasure to have you. Just see, Brandon, you want to go next?
No problem. Hi, everyone. Brandon Kramer, Strategic Engagements Manager with Autodesk Research. Here paying attention to various new teams coming up on the radar from new technology point of view, from a collaborative point of view. So, yeah, happy to be here.
Happy to have you. Perfect. I think I covered everyone. If I did not, feel free to either raise your hand or just yell out. Otherwise, I'm going to keep things going. Well, yeah, and thank you to all the panelists for joining. With that, we will get things on the road for session 2. iBlades is presenting first for session 2. So feel free to share your screen.
Okay, can you see my screen?
Yes.
All right, thank you. Should I get started?
Yes.
Okay, perfect. Hi, I'm Jorge Fernandez, CEO of iBlades.ai. We build secure edge networks for AI-driven real-world data. When you don't have a trusted network, an IT team, or time for complex cybersecurity, iBlades provides that for you. Our mission is to make cybersecurity simple, reliable, and autonomous where traditional networks fail, at the edge. As AI moves into the physical world, edge security becomes the bottleneck. We're not an early stage theory. We're deployed and engaged across defense and mobile denied environments. The United States Air Force Blue Horizons proof of concept is a successful demo that we did and we will do to the Joint Chiefs of Staff in May. And Guardtron and CyberPlus assembly at Thales clear facilities with NSA aligned chain of security. The problem, edge security is fragmented, costly to deploy, and humans are the weakest link. Manual key handling, certificates, and configuration. Threats are evolving with AI-driven attacks, plus harvest now, decrypt later risks as quantum timelines compress. Let me introduce you to the solution. Netron secures AI, data, and communications outside the data center, autonomously without human key management. It replaces fragmented systems with one unified platform, deploys plug and play, and is quantum ready and supports secure provisioning through Thales manufacturing. The market. Security speed, spend, is shifting from centralized cloud controls to distributed edge networks. Our target subsegment, edge encryption, mobile distributed assets, and legacy retrofit is about 25 billion today and growing at about 12% annually with rising PQC budgets. Let me introduce you to Netron. Netron is delivered as a peer-to-peer secure network fabric, mesh, self-healing, self-generating, and rotating keys. Beta tested show high uptime in the 9 environments and faster setup versus legacy stacks. This is not an integration roadmap. It's a single hardware secure fabric that converges with multiple categories of vendors delivered separately. The point is fewer moving parts, less operational fragility, and far less human handling. Quick note on economics. A typical enterprise stack creates large cybersecurity ops overhead by converging firewall, VPN, NAC, ZTNA, MDM, key management into one fabric with a unified dashboard and autonomous key rotation. We materially reduce admin and incident workload, often tens of FTEs worth of effort. Competition. Incumbents assume trusted networks, centralized control, and human key management, assumptions that fail at the edge. Netron is plug and play, unified, and built for untrusted environments with zero human key management, lowering time to deploy and simplifying total stack complexity. Go to market. We leverage partners in defense, the Air Force, Emirates Airlines, Dominican Republic Customs, and the Bird Foundation, then scale via systems integrators across international governments, global enterprises, and the military intelligence community. Our business model, mission-critical hardware deployments plus high-margin recurring software license. Netron user licenses, device management, and support maintenance. Near-term plan of $6 million for 2026 for 6 key accounts and a SaaS-like margin profile on licenses. Team, I've participated in 2 IPOs and 1 M&A exit. Our CTO is a former KLA 10-core VP, Stanford Computer Science. We have leadership across the Air Force communications, digital banking, UAV product, and supply chain operations. In summary, we have proven leadership, real demand, and a product built for the unavoidable future. AI systems operating in the real world over untrusted networks without human security overhead. We have already validating secure AI data feeds in the Blue Horizons environment. They ask, 10 million strategic scale round to transition pilots into scaled production, PQC hardening certification, expand across defense, aviation, and customs, and scale manufacturing international channels. As I mentioned, our 2026 target 6 million, with a target at 2030 to be 178 million plus. Thank you.
Perfect. Thank you. Thank you so much. Okay. Feel free. Oh, for this session, I'll remind everyone, feel free to raise your hand, or if you can't raise your hand, it's under the React in Zoom, but if you can't find it, which again, I've had issues in the past myself, feel free to just jump in and feel free to ask questions. All right. I will, sure. Did someone have something?
Yeah. Hi, Jorge. Thank you for the great presentation. I know you mentioned you're projecting 6 million this year. Do you have an idea of which customers that will come from, and what's the progress towards getting to that milestone?
Yeah, so we're at the run rate of that at the moment. Our current customers include obviously the Air Force, as I mentioned, In-Q-Tel, Emirates, UAE, Central Bank, and similar types of brands where essentially anyone that today has a transaction that will have value in 5 years, the whole notion of harvest now decrypt in 5 to 10 years is a serious problem, meaning that everything you have today in your enterprise is going to be decrypted, is accepted that it will be decrypted in the next 5 to 10 years. And we're the first ones to market with an edge solution that we completely solve that problem. So we're well into that 6 million this year. Obviously, with those kinds of brands could be much higher, but they also move slower. So trying to be on one hand conservative, but on the other hand, a very high upside for this year.
Thank you.
I have a quick question, actually. So a great presentation and great product there. Is your technology under ITAR compliance requirement, any chance, or?
No.
Oh,
We
okay.
can sell to anyone, anywhere except the usual suspects.
Okay. Okay, great. Thank you. All right.
Cool. We have time for, I think, one more question. Otherwise, we could keep things going. All right, we'll keep it going. Thank you so much,
Thank you.
Jorge. Um, Feel free to leave your information in the chat for anyone to reach out to you. If you know, I'm sure there will be some folks reaching out to you. And yeah, thank you for the presentation.
Thank you.
Yep. Next up, we have Tara Grit.
Hey guys, can you hear me?
Yep, loud and clear.
Cool. Thanks for having me. I see a lot of familiar faces. Good to see you, Hyundo and Bahare, and everyone else I've met at other events along the way. I think we'll just keep running into each other until we work together here. Um, yeah, my name is Sam Nagar. I'm founder and CEO of a company called TerraGrit. My background, I am a serial repeat founder. I sold my last company to Siemens for 480 million after growing it to 25 million in ARR. This new company, which I'm trying to share here, let's see. There we go. There we go. Can everybody see this?
Yep.
Perfect. Yeah, so this new company is also off to a great start. I spent a few years at Siemens, being an executive there, and this new company is about 2 years old, but not going to feel like a 2-year-old company. We have 150 employees. We have 84 Fortune 500 companies on the platform, last I counted. We have gone from 0 to 5 million in ARR in about 5 months, give or take. We took our first dollar in like late August, early September. We have raised so far just shy of 25 million, like 24.5 million, from mostly our customers. So like Intel was a customer, Intel Capital invested, Dell Technologies Capital, Nextera, Merck, a pharmaceutical company. We've taken some private VC money. General Catalyst is one of our largest investors, and Recursive was an early investor. If you guys know Itamar over there, but yeah, things are in pretty good shape for the new company. We're very excited. Just to share with you guys in just a few minutes here what we do. We focus on this problem statement, where, oops, there we go, where as a large enterprise that has a physical space that's very sensitive to change, going through this journey of introducing pilots, trying new, ideas that you might have, again, whether that's in a factory, trying visual quality inspection on a production line, a warehouse, doing, introducing robots and AGVs, retail stores, introducing, self-checkout kiosks, to all kinds of other environments we work with, like nuclear plants, theme parks, Universal Studios is our first paying customer. All of them, tons of these different environments that are very sensitive to change and have a graveyard of failed pilots behind them of things they were trying, projects, to try to improve those environments, but just doesn't seem to work. 19 out of 20 pilots fail. Each of these companies gets through maybe 10 or 12 pilots a year. And but when you get that 1 out of 20 pilot that actually does work, you create massive impact. We watched Volkswagen figure out visual quality inspection after spending, 2 years, 25 million euros, managed to improve and increase or decrease the amount of time it took to produce a car from 59 seconds to 58 seconds, added 1.8 billion euros to their top line. Our vision as a company, we just want to make events like that happen more often. Our idea is basically to create a virtualized environment, a virtualization engine, to run pilots. And so basically a tool, virtualization tool to run as many experiments as possible in a short period of time. If you compare that to basically simulation tools, digital twin tools that are out there, they're pretty much only designed to be used by engineers. They take a lot of time to implement. They're extremely expensive, both from again, time and cost perspective, and they're just not practical. We see a lot of these companies spend, multiple years building out an environment. And then, when you want to run pilots or projects or try some changes, spending months, with each of those ideas, each of those projects, for fundamentally a numbers game. So we basically made the first of its kind virtualization tool for this that makes it scalable, fast, practical, easy, to be able to make changes in a space before trying it out physically. Um, just to give you guys a quick preview, we actually brand ourselves as the Canva of simulation, just like Canva disrupted the 40-year-old Photoshop. We're disrupting a lot of these 40-year-old simulation twin tools. You can compare one simulation versus another, kind of evaluate which ideas make more sense for you to translate to the real world. We have a library of all kinds of assets. We have partnerships with companies like Boston Dynamics, Honeywell, Schneider Electric, and all kinds of companies that add to this library. Basically, you build out your environment. Whether it's the layout or what's happening in the environment. We've pioneered new interface for this that, again, even novice users, folks that never would have otherwise been able to use a simulation tool, can do that. It's actually inspired by a video editing tool. You have a timeline at the top. You can kind of stack your Lego blocks left to right for what happens in sequence, vertically for what happens, in parallel. You can build out relationships between, different aspects of the environment. Like, for example, this person, the material handler, is doing this operation on this asset affecting this KPI. First time ever in history, you now have interns, analysts, regular managers, product managers, innovation teams, digitalization teams, a massive unlock to the market of who can validate ideas virtually before they can move it to the physical world. You have more advanced interfaces for power users. You can do prompt-based editing, prompt-based creation of scenarios. We leverage AI. I know investors love to hear that. We get you about 80% there for any scenario you want to generate with AI, and then you kind of fill in the rest with these easy to use interfaces. And then basically, as you make whatever changes, in this case, we're inserting a computer vision application. You can change the layout, change the process, whatever it is, as you go and you submit the change. Basically, you go back over here and you're going to watch these graphs and these KPIs update in real time, give you an idea of what the new performance looks like. This kind of sits in between one of those, old legacy 40-year-old simulation and digital twin tools, and maybe you hired like an MBA kid or something to, make some financial projections in an Excel sheet, and you make that, poor, Excel slave just do sheets and sheets and sheets and 12 different spreadsheets of all your ideas, and you're asking them to combine. Okay, what if we combine idea one and two, and you're just making that kid regret his MBA. But
30-second
anyway, yeah,
warning.
yeah. I mean, that's basically it. This, we're doing really well. We'd love to work with anyone who's got an interest in this. We're well capitalized. We're making money. Yeah, yeah. I don't even need the 30 seconds. I'm good, Asher.
Perfect. Awesome. Rachel, go right ahead.
Hi, I'm very excited from like a continuous process improvement realm. And I was wondering if you had already connected with like the Air Force Continuous Process Improvement Office. If not, I could get you connected. I'm working on my black belt currently, and this would do a lot of the work for me. So who wouldn't necessarily want that? I also know the POC for the Army, but if you're already connected, let me know. But if not, I could get you connected.
We are not. I don't think so. Rachel, I'd love your email address if possible. I think we're talking to someone from the Air Force. I'm not sure if it's a continuous process. If Mitch is on the call, maybe he can remind me who we're speaking with. I do sometimes lose track of all the different customer engagements.
Yeah, not that specific department, but I'd love to look into it for sure.
Thank you. I'll drop my information in the chat.
Really appreciate it, Rachel. Thank you for the feedback.
We have time for at least one more question.
Or I was just that clear that no one's got
Exactly.
questions. So.
No one. I mean, that's good
Actually,
too, right?
I had a quick question. Sam, really impressive what you built here. Does the platform model energy draw?
It does. We support that. A bunch of customers do that. And we actually have a lot of energy customers in general, BP, NextEra, like utilities and oil and gas guys. But even from a facility perspective, you can also model the energy usage and all that too.
Love it. Super impressive. Well done.
I appreciate it. Yeah.
Cool. Awesome. Thank you so
Are
much for
there
the presentation.
Quick and
Oh,
easy.
just a quick question? Are there case studies we can access just to see how it's been used in corporate?
Absolutely. Yeah,
Yes,
we
right?
I can send you some materials. Please just give me an email address in the chat.
Okay.
I'll forward you all kinds of stuff. If there's a certain area, because we work with retail, manufacturing, supply chain, energy, like all kinds of verticals, it was, maybe not immediately well advised. I don't recommend a first-time founder ever do that. But at least it worked for us, so I can send you all kinds of materials.
Okay, appreciate it. I'll drop my email in the chat.
perfect. Awesome. Well, thank you guys. And yeah, sounds like you got some homework to do as well. And we'll keep this show going on. Thank you for the pitch.
Absolutely. Thank you, Asher. Thank you,
Yep.
everybody.
Yep. All right. Next up, we have M4 Labs. Feel free to get started.
Good afternoon, everybody. I'm Jeff Riley. I'm one of the founders of the company. We are going to switch gears from what we just looked at to something a bit more esoteric. Let me see if I can share my screen here. Maybe, maybe not.
If not, let us know. I think we might be able to pull it up on our end.
Yeah, you're gonna have to pull it up. It's not working on my computer, unfortunately. I'll just tell you when to turn the slide if that's okay, Asher.
Yep, that's totally fine.
All right. All right, so the name of the company is Amphora Labs. We are a materials-based company, so we're looking at creating brand new materials for different industries. And we'll walk through a little bit. It is an AI-enabled company, but we do have synthesis as well, so we can go all the way up to about 100 liters, give or take, to create a product in this space. Next slide, please. Problem is traditional materials R&D. A lot of us come from the biotech industry as well, so we understand that there's a huge issue traditionally as far as trying to take a product from, hey, I got a great idea, all the way up into an actual product that generates revenue. There's a large universe of molecules out there, 10 to the 180th roughly, and to date, human beings have looked at roughly 10 to the 8th, 10 to the 9th number of those things. We think, given AI, we could do it much better and faster. Next slide, please. So AI methods traditionally have failed because promising candidates really aren't manufacturable at spec. The biggest issue we have found when we talk to a variety of groups is the synthesis component. So not necessarily coming up with new compounds, but coming up with new compounds that you can actually make. And we think we've bridged that gap given our AI that we have put into place, and we'll talk about that next. Next slide, please. So we're leveraging proprietary IA tools. We built our own foundation. It's a molecular physics foundation, and the basis of a lot of that is mathematics, and we'll go a little bit into that. We have a variety of physicists and quantum folks on the team, so that's the way that the code's been written. But that is in combination with physical lab validation. So as we come up with a product, we do lab in the loop. We basically go to a lab. We're fairly lab agnostic depending upon the industry, and we test it, and then we iterate it as many times as necessary to get to a product that makes sense. Next slide, please. So I won't go into the detail here. This is actually a pitch deck for venture guys. We're using a neurosymbolic knowledge graph. This has been built from scratch. We basically have the ability to use generative AI to create brand new ideas, brand new algorithms, and then we preload the parameters of what we're looking for, and out the back end of the system pops a variety of compounds that have a variety of we think characteristics that make them manufacturable. Next slide, please. Again, very complex slide. I won't go into it. Basically, just the flow chart of how we're doing this thing. So on the front end, partners, and we do have partners, R&D collaborators, can give us the set of parameters that they're looking for. I'll give you a couple examples shortly. And then our system goes through it and basically designs what we like. Again, the labs that we're using tend to be on the polymer side of the equation. And we'll talk about that in a second as well. Next slide. So as noted, we're looking at primarily polymers, performance coatings, and specialty chemicals at this stage of the game. We can probably do pretty much anything. It's a gigantic materials market overall is $27 trillion. Obviously, we're not going for the entire market, but we are looking, we specified polymers specifically because they're relatively difficult. And a lot of the biotech related stuff applies to what we're doing here, biotech AI. So that's why we're going in this particular area. So you can see some of the innovative trade-offs that we're looking at and some of the starting points with respect to creating a brand new material. Next slide. So focus one, again, performance coatings. We have a collaboration that we're working with HII. And that group is the largest shipbuilding company here in the United States. They make all the aircraft carriers, submarines, etc. So we are working with them on new coatings for hulls, essentially, as for the large ships as well as for the newer USVs, the unmanned surface vessels. So basically, we are a dual use company, if you will. So we're looking at coming up with this, and we'll be meeting with these guys again next week, actually, and at their facility, their R&D facility, to show them what we've come up with to this point in time. Next slide, please. We're also looking at something a tad more complex, again, in the Department of War area, and that's hypersonics. There's a huge set of issues when anything goes faster than Mach 5, and the mathematics associated with a solid turn into a liquid, into a gas, are relatively complex. Our AI can fix that, or at least understand that enough to where we can come up with some brand new materials that will hopefully be able to help on some of the supersonic flights that are out there. Next slide, please. Team, I'm Jeff. We have most of our folks reside in Salt Lake City, which is where our tech team is. We've got a fair number of folks there. We've been self-funding for about a year. We've not raised any capital to this point in time. But you can see some of the names here. Two of our gentlemen, Wes Spence and Christian Dunbar, are both retired SEAL captains. They were in the SEALs 25 and 30 years, but they've been out in the business world here for the last few years, and we're working with them on a couple of the verticals that we're working in at this point in time. We tend to be very science oriented. Again, not a SaaS-based system. We are a RAS-based system. So our job is to deliver results to our customers, and we're just not a software company at this stage of the game. Next slide, please. Next slide. We're done. That's it.
Sure. Awesome. Opening up the floor for questions. You guys know the drill by now, hopefully.
Okay, I have a question.
Go for it.
Sorry, raise my hand. Hi, Jeff. So what kind of inputs do you need for your software platform in order to design the material? What kind of requirements from your customer you usually get?
We get a very large number of parameters that they're looking for. So for example, the primary one for the epoxy-based polymer that we're creating for the US Navy vis-a-vis HII is we're looking at corrosion, primarily looking at anti-salinity, self-healing, all the parameters you would think. I mean, believe it or not, these giant ships actually have to be repainted or re-epoxied every at least once a year generally. Oceans are very tough on these things. So again, we're trying to get to the point where we can create a safe self-healing property that again also reduces UV and signature on the ocean when you're going into enemy territory, essentially.
And your software, can it like suggest new item, I guess not new parameters? Is it like
Oh no,
generated?
it's generative. It goes through the entire
Okay.
system. And we've designed it to run 24/7. So obviously we're looking at customers' results, but we also have internal programs that we're looking at, organic photovoltaics, things of that nature, that is continually running and coming up with ideas on its own. It creates its own algorithms. Jepson Taylor, who's one of our team members, that's his expertise. He has a company called Viox, but we're looking at trying to really get the human out of the equation if we can, because frankly, the AI is significantly smarter and doesn't think linearly when it comes to a lot of the problems that we're trying to solve.
All right, thank you.
You're welcome.
Cool. We have time for
one quick question. How do you see the business model potentially evolving over time as you generate momentum with customers and as they're experiencing results? As you said, are there other opportunities for monetization that you might see in the future?
The primary model that we're going to follow at the moment is I would say non-traditional with respect to a lot of the software SaaS related programs. So there's an upfront payment when somebody partners with us. That's, to engage us essentially. We can take 10 years, basically reduce it to 3 months, give or take, on the front end of the R&D. It does take another 3 to 6 months to do the lab in the loop. Our system will continually get better and better because we're generating our own data, obviously, not just synthetic data or public domain data, but our own data. And we have access to other databases that are military, if that we're allowed to get into. So upfront fee milestones, obviously within that year to 18-month gap, time frame to do the project. And then the biggest nugget is frankly the royalties that come on the back end. In the materials industry, those range between 1 to 5%. So we anticipate starting to generate royalty revenue within 3 years, give or take. It depends on the size of the market, right? Depends on what that is and how far integrated we are for dealing directly with the Navy. That's one number. For working for a contractor that's in between the U.S. Navy, Army, Air Force, whoever, it tends to be a smaller royalty fee or percentage when it comes to those guys. That's the model.
Marissa,
And then the master model is spin outs of the company itself. So we're working with Temasek and some other groups to fund some larger entities. This little entity that we're funding here is the engine, right? The little engine that's doing the majority of the grunt work as far as the R&D, but the other entities that will be commercial entities that will be part of the overall ecosystem that we're building.
So what is your revenue this year?
We anticipate between $1 and $2 million. We're doing a pre-seed round. We've not raised a single dime up to this point. We have self-funded. We just got the deal with HII, which is Huntington Ingalls, if people are wondering what that stands for. And we anticipate to hopefully finish that deal by the end of this year, or not finish the deal, but deliver the product to these guys by year end.
Kathleen, last question.
Yeah, so ultimately you need to scale this up to really cash in on the IP, right? So you can get royalties, but unless I'm making this. So the piece that can you just like the go-to-market piece, you have a molecule, you have an application that looks great with a lab scale amount. How do you get that scale up? Are you leaving that for the chemical manufacturers to figure out, or?
There's two stages of that. So, right, we can come up with the great ideas. There's a fair number of competitors doing the same thing, and there's a fair number of folks that are doing the lab in the loop. But what people are not doing is the synthesis, the early stage, pilot stage synthesis of the products themselves. That's what we're doing. That's what we're doing ourselves, and we have partners that do that for us. There's another recipe. So there's a recipe for whatever the compound is that you're creating for that. But the recipe changes a bit when you get to the large scale manufacturing component, actually quite a bit. So when you're going
Absolutely.
to Williams or you're going to a DuPont or whoever it happens to be that's going to do the large scale manufacturing, that is another pivot that we're doing. So we're creating that recipe for them as well, but we will not be doing that initially ourselves. We do have a plan to look at doing that or probably 18 months from now, but we have to create what we think from scratch is more of a modular system of manufacturing. Think inkjets, laser jets, that type of thing, that are in self-contained units that would be then deployed around the world and somewhat mobile. But at this stage of the game, we're not doing that. We need to get the base set up first and then move forward. We intend to break even within the next 18 months. It's not expensive to fund roughly 15 to 20 programmers and BD people that are inside at this stage. So we should be able to have enough revenue coming from the other deals that we're talking to, which I'm not going to reveal because we haven't signed the dotted line on those yet, but they're with the usual manufacturer or usual DoD folks that you would think that you want, as well as some people that are not within there. So dual use, obviously the military government's funding a lot of the work because it is national security oriented, but we are leveraging that knowledge base to obviously go into the commercial side as well, primarily energy to begin with.
Yeah, if you're interested in connecting, please leave your email. I'd like to connect offline.
Asher, do you supply emails to everybody, or
Yeah,
how's that?
yeah, we'll get it set up. Don't worry about that.
Okay.
Yeah, Brian and I are on it.
Thanks,
Cool.
everybody.
Yep. Awesome. Perfect. Thank you. Next up, we have Tiger Vision.
Good morning, afternoon, everyone. How are you?
Doing well.
That's good. You can see the screen all right?
Correct. Yep.
Fantastic. Matt Coleman, president of the
Well,
company. I'm going to have Steve Welk, our CEO, here as well, coming in
Hey
soon.
guys,
Steve, how are you?
I'm doing well. Just slid in from NASA here in Houston. I'm glad I made it in time for this presentation. Thank you for providing this opportunity for us.
Good. We're going to go through the advanced LED immersive technology. This has been widely used just in the last 6 to 12 months since our company's been in operation. The original company was focused on entertainment, and we've moved this into simulation training, cyber AI, and also operation command centers as well, or space awareness. The I'm going to hand it over to Steve just to give you some highlights here, Steve.
Yeah, well, in the executive summary, you can see that we build LED printed circuit assemblies that create a scalable solution for surround reality. It replaces edge blended projection. It also replaces HMDs that are used in environments where they're providing training and information. We have developed the technology to a point now where it's compliant for defense and TAA, and we're on a pathway for BAA compliance. We're at a technology readiness level 9. And we've continued to evolve our patent portfolio with 13 utility patents in the area of immersive display technology. The key features of the technology is basically a blended immersive display environment where it's sort of infinitely scalable and provides users with a virtual reality without necessarily wearing headsets, if that makes sense. Yeah, the team that's been engaged on this has been, on and off over the years. I've led that in dabbling for a while when I first started to explore what's the trajectory of high density LED and what are its uses, and then, as Matt mentioned, just this past couple of years, identifying that really the defense sector and aerospace was really a great landing spot for this technology, and we formed Tiger Vision to pursue it. Yeah, and we've been able to get our technology integrated in a couple locations. One at NASA in Houston, where we just actually commissioned the display today. I was rushed back to my hotel here to meet with you folks. It was really wonderful. There's numerous applications that they see throughout their training facilities, and from engineering to actual flight training and space training. Was able to put a couple of wearables on today, which was pretty cool. I was walking around the moon and was actually floating around the ISIS station. But they want to transition from those old legacy products into something that we're offering. And so, as Matt mentioned, we're just getting started, and we currently have manufacturing agreements completed with 2 suppliers that are bringing manufacturing back here to the United States. We also still have access to supply in China and Asia, and that we've actually tooled and built several systems and tested them for their applications. And now we've been to a couple of different events and have numerous requests for quotes throughout the Department of War ecosystem and others. We're really busy, and we need some help growing and getting scale. Matt?
Yeah, as you just probably saw, the ask is an $8 million raise. This is a seed round that we've got that we're looking at a safe note at this stage. I'll just show you. So these are some of the other systems. The back shot here without the staging is the system we currently have at NASA. It's 28 feet wide, 10 feet tall. We also have a 12-foot system at Patrick Space Force Base in Florida as well. We're also in deep discussions with BAE, who we recently met in Orlando a couple of times, and in Australia. I'm based out of California, by the way, so just even though I'm from Sydney, just thought I'd mention that. Most of the team is in California, actually. We're a Nevada C Corp. But as you can see, this is a perfect move forward from anybody that uses projectors. There's a clear inflection point. Boeing, Lockheed Martin, all the major primes are looking at LED because the cost for maintenance for the projection industry is so expensive. A bulb in a 28 projector dome will cost $60,000 to replace. It's costing customers millions of dollars. We have one input, and it has 8K to 12K, which is triple Netflix quality. And this is when it's blown up to 4 stories high, domes as well. As you can see, we're welcoming investors to Houston mid-March, and we've also got a walkthrough at Patrick Space Force Base as well. I don't really need to tell you how big this market is, but happy to, if you want to request this presentation. This is just a highlights package today. We do have $40 million in requests for proposals right now from 14 RFPs. We're receiving them virtually on a weekly or daily basis. We just got 2 from CAE. But you can see some of our, the NASA and the aerospace industry and Space Force have been really key initial clients. This is one of the circular
We should start wrapping it up, guys.
Yeah, no problem.
Cool.
I'm not going to run through too much of the financials outside of, there's a breakdown of use of funds. This is one of the other systems. And we've got a 5-year business plan, but we are expecting minimum of revenues of 28 million this year. And the pricing ranges from $500,000 to $3 million for the smaller systems, up to 65 million for a 4-story 360 dome. So yeah, that's us. There's a full team advisory board.
Yes, and we are agnostic. We had a question from someone. We are agnostic in terms of input.
Yeah, and that's us.
Sure. Opening up the floor to more questions. Feel free. Beyond if you guys are agnostic to tech or software.
Steve, you might want to prompt the cyber AI keynote you did at Embry-Riddle in Daytona last week, just to give them a flavor if there's a message coming in.
Oh, yeah. Well, there's so many applications in cyberspace, and just that we help to advance awareness in all respects to the cyber side, which is really important. We've been having additional meetings with companies that have basically digital twins that are live updated of our planet, and becomes a useful geospatial platform for government and agencies. And they're looking to get advanced awareness within that powerful software. And if they're just staring at a laptop or a cell phone, or perhaps just a monitor hanging on a wall, that's a little bit of information. But what we provide is that supercharged information that allows them to make critical decisions quickly. And in fact, today I just learned about a study that NASA conducted where they were looking at all the wasted time when people are trying to go through their daily workflow, and just what it takes to grab a pencil or turn your head or whatever it might be. And they were looking at all the metrics of just interfacing with data on displays. And it was really an interesting exercise. And we have the perfect solution to be able to shorten time and be able to make quick decisions and have an auto-curated environment, if you will, on steroids that gets all the right information to the right people and provides a realistic training platform. It overcomes things like the grays that they see in projection where they need black. And so, well, we've got black, and never thought black would be so important, but it sure is in training in space. Yeah.
Yeah,
So
Andrew, any other questions? Just sorry, Steve, because I know
yeah,
we're
sure.
probably close to our time.
Yeah.
All right. I think that's it for now. But yeah,
Great.
Matt and Steve, feel
Thanks for
free
your
to
time,
leave,
guys.
yeah,
Yeah.
feel free to leave your contact information in the chat. I'm sure there'll be some folks reaching out. Next up, we have Lemco.
Let me see if I can get my video going here.
Let's see if, yeah,
Oh, here it is. I see. Okay.
perfect.
Video. All right, there we go.
We see you.
All
Hello.
right. Hey, good afternoon, everybody. Being the last person, I'll try not to go over.
Second to last. Actually, there's one person after you.
Oh,
So
there is. Okay.
yeah,
Okay.
doing good.
Okay. It's been a busy day, so I haven't kept track of all my updates today. So let me go. Okay, here we go. Share. Okay, can you see that? Okay, my screen.
It's loading for me still. Yep, we can see it. Go right ahead.
All right, great. I'm Brian Ponte, Vice President of Sales and Marketing for Lemco Corporation. We're based in Schaumburg, Illinois, outside of Chicago. And just a quick background: we've been in business 20 plus years now. We pioneered in this is for 5G, 4G networks. We pioneered what's called network function virtualization, mobile edge computing. We have a 20-year track record of successful deployments with DoD, international partners, operations experience with commercial, military customers, and like I said, we mentioned it's really 5G networks these days. We started off with 2G, went through 3G, 4G, 5G, etc. I'm going to talk today a little detail about what we're doing in the nuclear power industry, and the reason is that kind of brings together the three themes, or at least I understood it, of the session today, and that's IoT, cybersecurity, and AI. And we've been working with Constellation Energy. They're the largest energy producer in the U.S. They have the largest nuclear fleet. And also a partner company of theirs that now acquired some of their technology that we were working with, called Studsvik out of Sweden. And we did a successful proof of concept deployment at the Dresden Nuclear Power Station, which is south of Chicago, near Joliet, Illinois. And here's a, minimize this. Some photos of, we were inside their turbine building. We had a couple towers that were deployed on. You can see there's a sensor screen example. We had several hundred sensors, different types of sensors that we had deployed. The picture is a lift station. Lift station is where they manage water coming in and coming out of the nuclear station. As you can imagine, water is a very important commodity there, and water temperature is very, very important issue. And then here's a photo of digital workers using this is actually a Motorola push-to-talk phone that was using the 4G network as a data source. We also had smartphones, iPhones and such that we did in the proof of concept. And as I mentioned, this is sort of the security, the IoT, and the AI nexus in this deployment. And security is very, as you can imagine, in nuclear power plant, security is very, very important. I mean, the first time I ever went in one, I was surprised at how many people walked around with assault rifles and large backpacks of ammunition and so forth to secure the plant. But that they're really concerned. This is more on the cybersecurity, external threats, internal threats. People inside that might be trying to do jamming or interception of the signal, the RF signal. Facial recognition is also that's something that they want to have is more facial recognition of who's in the facility. And if you look at IoT type applications, like I mentioned, water temperature is very important. Vibration, having security around entry points, radiation sensing is very important in a plant when um, inside of a facility. You know, if you're working in areas where there's a lot more radiation, you right now they have they have little devices that add up, but you have to take it off. It's a very manual process, and we can automate that. And then if you look at the AI component, you have thousands of sensors, and nobody can sit there and manage all these sensors, the things that they want to keep. They want to automate it. They want to do things like, again, going back to water temperature. If the ambient temperature is a certain temperature outside, and they're producing a certain amount of power, and the temperature in the water coming out of the plant or going into the plant are certain levels, they can track that and understand what's happening with the and how to manage the cooling of the plant. Video facial recognition, it's not only facial recognition of people, but also video of being able to video things that are happening in the plant. If something unusual looks like it's happening, can the video capture that, and through AI application send signals, and then also targeted alerting. Things are happening, for example, in a plant. What they call hot work is very critical. That's welding, things that could cause a fire. They have these things called robotic fire watches. If there's a fire, they can target specific people in specific areas, and um, um, and send alerts to targeted people to make sure that responses are managed very well. So that hopefully that sets the stage, kind of in terms of the application and so forth. There is a customer that we're working with our partners, and I can't say the name, I can't say what they are, I can't even say what they do, but let me just put it this way: it's very, very high security. And so one of the aspects they have is they want to have wireless in their facility. They can't do wireless right now. They can't do Wi-Fi. Wi-Fi is not secure. It's got security gaps, and so the other thing is, in terms of if they want to put a private 5G network, they cannot have it connected to the outside. It can't be connected to a cloud. It can't be connected to the internet. It's got to be 100% air gapped and on-prem. And it's a very large and it's very spread out facility. I mean, these nuclear plants are, tens to hundreds of acres in size.
30-second warning. I don't know if you're able to. Yeah.
Okay, all right. I'm going longer than I thought. So anyways, they don't have communications, but what we've been able to show them is that our 5G system, and also with the over-air security of 5G, can support their security requirements. And really, just to get to the meat of what we do, our product is software. We integrate it into a 5G radio to create what looks like a Wi-Fi type of deployment model. So these systems can be deployed around the facility and use the facilities enterprise network to create a fully functional 5G network in the facility, and then add all the other IoT and AI applications on top of that. I'll just go with call to action. So we're just basically looking to work with people who might know or have a need for this type of a solution. Again, really focusing on the security and the ability to add the AI to the solution. I'll stop right there. Any questions?
Absolutely. Yep. Opening up the floor. Feel free to jump in whenever you guys are ready. I can start with the first question. Can you talk a little bit? You talked about nuclear facilities. Can you talk about either other use cases or other government traction that you guys have or have seen?
Well, I mean, yeah. So I focused on the nuclear station because of the security and the IoT and the AI. We've been working with Eagle Point in tactical networks for military use, for first responder use. So because of the architecture of our system, we can go onto vehicles. We can even go as small as man packs that are battery powered and create rapid response, uh, uh, you know, 5G network capabilities. So we've been developing opportunities in Taiwan and Japan, for example, where they have significant earthquake activities and typhoons, and there's major concerns that some sort of a major event would create the lack of 5G. Now it's becoming 5G mobile networks. And in today's world, I mean, if your phone goes out, I mean, everybody pays from their phone, and they actually do it more in Asia than they do even in the U.S. They do all their bankings on their phone. They pay for stuff. So losing your mobile network capability is can be devastating.
Absolutely. Yeah, and can you talk a little bit more? I mean, I guess then also like denied environments, right? For environments, yeah, like you mentioned like the frontline adding a pack. So like that frontline system. Oh, Ben, you want to ask another question? Go for it.
Sure. Have you worked at all with Dan Wright and the Armada team?
No, I'm not familiar with them.
They're a unicorn edge compute company putting essentially data centers at the edge. But I know that they've had SpaceX as part of the comms stack that they have there, and I know that they've started engaging around other comms platforms to integrate there on an as needed basis. But it might be something worth looking at.
Okay, all right. So you said it's Armada?
Yes.
Okay, all right. I'll look them up.
Perfect. Awesome. We have time for one more quick question. Speak now, forever hold your peace. All right. Thank you so much, Brian. Really
Okay.
appreciate the presentation.
Right.
Last but not least, we have Incase joining us today. Incase, feel free to start sharing when you are ready to go. Give me a second. There we go.
Can you see my screen?
Yep.
Yeah. Hi, everyone. My name is Rajesh Patil. I'm the Chief Technology Officer for a company called Encase. We're primarily into full stack quantum encryption. Sorry, let me just go through. So about Encase, we do our own software and hardware. We do not white label anything. Everything's been homegrown, designed, built, and assembled together. We have 7 patents in US, just filed 1 patent this week, 10 years of innovation behind it. Everything compliant with NIST, as well as all the FIPS that is required in this space. So everyone's aware of PQC, right? The post-quantum cryptography. For us, the approach is different. We don't feel that PQC by itself is secure enough. So our recommendation is based on enhancing PQC with a quantum source, typically a QRNG, which is a quantum random number generator, and so on. There are multiple ways of doing it, all the way up to QKD, which is considered to be the holy grail of quantum encryption. So we do the entire gamut. Encase platform is what we offer as a platform that enables enterprises to go from where they are today using classic encryption, which is at risk from both harvest now, decrypt later, as well as quantum computers coming up. We have 4 parts to it. Quantum Mesh is a product that actually encrypts data in transit. The Fabric encrypts data at rest. Blueprint is a process through which we help companies identify the crypto assets they have in the organization and come up with a risk profile. Governance framework is something that's ongoing as you evolve in terms of the compliance requirements for all of this. It's still a lot of moving parts there. We help organizations kind of understand where they are and where they need to be through that process. The blueprint and governance essentially goes to the entire infrastructure and code base and applications that you have, every single crypto asset that's kind of buried within the organization. We find them and we kind of classify them based on where they are in terms of the risk profile. A quick deep dive on the secure mesh. What we essentially do is we provide a quantum key layer, which is the one in the green. We provide nodes for network appliances that they can take the key from there and use it for encryption and decryption. The method through which we do this is called out-of-band key generation. So most of the network appliances can accept a key from outside out-of-band generation. This makes it easy and does not have any more dependencies on any of the network providers. Every company would have a heterogeneous environment, Cisco's, F5, you name it. One option is to wait for them to come up and support quantum encryption. The other option is to kind of go ahead and do this with a quantum key layer and gives you a lot of crypto agility and an abstraction. We also have a couple of other products as a part of this. We provide the quantum random number generator, which the source of the randomness is quantum, and also crypto accelerator in case where there are transactions that need to run into thousands of transactions per second. The second part to this is the secure fabric. So we have our own KMS, quantum key management service. The existing HSMs need to be upgraded to support quantum keys going forward. So that is a bit of a work, or you end up buying a new hardware appliance to make it work. So we provide a level of abstraction that kind of generates the keys for both classic and quantum encryption, and leverages the existing HSM as a data store to keep all of those keys. We also provide private C and PKI services for internal use and have a full integration with third-party integration services. The whole thing comes together when you put all of it. So it takes care of all your encryption need, data in transit, data at rest. They talk to each other, entire ecosystem under one platform. Quick about the cost of delay. SEC just went through a process of understanding what it means. So if you're looking at a proactive migration, it's about 10 to 20 million. Again, depending on the size and the complexity of the organization. If you're going for reactive, it could be much, much, much higher. So this was done by mathematical modeling by SEC. There's a report that's out there. So the goal is to recommend organizations to start looking at this much early on and come up with a migration plan. So you're looking at a 35 plus billion non-discretionary spending market opportunity. This is not something you could delay with the CNSA 2.0 coming out. The timelines are between 2025 and 2032. Most of the recommendations to complete the migrations are on or before 2030. Very difficult to size a market given that the encryption is so embedded in everything. But looking at a bottom-up analysis, you're looking at about $35 plus billion worth of opportunity. NCASE has raised $2.5 million in seed capital for our expansion. We're looking to raise another $10 million for the next round. Just a quick view of how the whole solution would work. If you're looking at a classic topology across any organization, you'd have cloud, you have partners, you have remote users, you have multiple offices, you have an existing infrastructure. We do not change any of that. We'll put another layer on top of it. It's essentially a VM. It can be a Raspberry Pi. It can be a drone. It can be anything that can use a compute and a network connectivity, and we can deliver the keys, quantum safe keys to where you need that to be. And then you could use the keys to use your existing network to do an encryption and decryption. Again, the advantages, again, it's quick. We can turn this around very, very quickly, deploy this network. We can go from quantum risk to quantum safe in a matter of weeks and months than years using our out-of-band key mesh. We do have a working network, quantum safe network across 6 locations across the globe, running out of AWS data centers that's delivering keys. It's a proof of concept and art of the possible that we have. If someone's interested, we can show the demo and show how the whole thing comes together. That's pretty much it. Pause right there.
Awesome. Thank you so much. All right, questions. Let's open up the floor. It's the last presentation, so if you're waiting until now to ask a question, now's the time. Feel free. I do have one, but it might make me come off as a quantum novice. I just kind of want to better understand, like, because I've seen some crazy solutions for random number generation. like lava lamps,
Yes.
a water bottle with a bunch of dice in it, all kinds of fun stuff that it's all outside the box. I wanted to better understand as a layperson, right? Bear with me now, as a layperson, how does your random number generation work? Or I don't know if you're able to reveal or if that's a secret sauce, but would love to understand that a little bit more.
The source is a photon. So, and there is a scale called Shannon scale to measure the effectiveness of an entropy. So anything that comes from a quantum physics tends to be the highest level. You could use multiple sources. We also use for a smaller form factor for like an 8-pin SIP, we use a radioactive decay as a source of
Okay.
entropy. But the highest possible entropy that you can get is from a photon.
Okay. Oh, interesting.
Yeah,
That
and
makes
then
that
we are
makes sense.
also in the process of getting our certification from NIST for something called an ESV certification. It's an entropy source validation. So NIST goes through a comprehensive process, almost takes about a year to validate the source of entropy. And then if it is good, then they give you a certificate. And that's what we are doing right now.
Cool. That makes a lot of sense. And then yeah, feel free to jump in anyone if you have questions. Otherwise, I have a few more honestly about the
I have
the
a
the
question.
sure
I'm
go.
also a quantum novice, so forgive me if
Sure.
it's a dumb question, but
No,
to my
please.
knowledge, we're not quite like in a post-quantum world, right? To some degree, we're getting there, but there's a lot of these PQC companies popping up. So how do you measure the efficacy of your solution against other solutions?
Well, there are multiple ways to address this. And see, the underlying building block is post-quantum cryptography. That's the new set of algorithms that have been published by NIST in August of 2024. So every single solution that you are looking at in the market will have been built on top of it.
Okay.
There are a couple of nuances there. The first thing is PQC algorithms are still based on classic mathematics. The math so complex that quantum computers will struggle to break it. But our solution just doesn't rely on mathematics. We enhance that mathematics with quantum attributes like a QRNG or a QKD, depending on the use case and the scenario. Essentially, what it does is, for whatever reason, if PQC gets compromised, you're still not at risk using a hybrid solution. If you just use plain vanilla PQC, we have a lot of unknowns. Again, this is not fear mongering, but that's the reality. If you're doing it once, you might as well do it right, so you don't have to go back and fix it all over again. So we are probably one of the two companies out there with a full stack quantum encryption that integrates both hardware and software from the same company. We have just one throat to choke on both ends.
Cool. Thank you.
Sure. We have time, I think, for one more question if anyone wants it. Otherwise, we could call it here, given a little bit of time. Okay, awesome. Thank you so much, Raj. Feel free. I see you already left your contact
Yeah.
information in the chat. We really appreciate your time. Thank you to all of the companies on the panel who joined. Really enjoyed having you. Thank you for making this happen. And I'm looking forward to seeing you guys next month at the Energy and Clean Tech Showcase. Have a good one.
Okay. Bye.
Thank you.
Yep, absolutely. Pleasure to have you, Kevin. Bye, everyone.